Have you ever come across a website with amazing animations or fun little browser games and thought, hmm, how did they even do that? Or how did they even make that? Well, the secret behind achieving those smooth animations is HTML5 Canvas. Now, HTML5 Canvas is like a digital artboard right inside your browser. And in this video, I'll explain what Canvas is, why developers use it, and by the end, we'll draw our very first shape together. Now, without any further delay, let's get right into the video. HTML5 Canvas is an element that lets us draw graphics using JavaScript. Things like shapes and lines and images and even animations. Now you can think of it like a digital whiteboard where HTML creates the board, which is done by using the canvas tag, and JavaScript becomes your marker to draw on it. And as mentioned before, it is commonly used for browser games, visual effects and animations, and also to make interactive charts or simulations. Now that being said, let's set up a simple HTML file and create our first canvas. And for doing that, I'll head over to Codin.com and use its compiler, which also has a web dev feature which makes us easier to display results instantly. So inside web languages, I'll go to web dev, and here's our boilerplate. Now, for now, I will not include anything inside the body except for a canvas tag. So here we have to link a canvas tag. Let me just increase the size for you guys if you don't see it clearly. Well, it should go as canvas, and we'll close the canvas tag, and that is about it. We'll give it an ID of my canvas, and let's give it a width of 400 and a height of 300. Now this is essentially giving a height and width to our blackboard, or let's say whiteboard. Now as for the styling, let's make our canvas visible by giving it some styles. So inside body, we'll remove all of this boilerplate at first and put display flex, and then justify content center, align item center, and then a height of 100 view height, and then a margin 0, I meant to type 0, and padding 0. Now as for styling our canvas, we will select and style the canvas tag as follows. So canvas, and we'll give our canvas a border so that it is visible as a proper whiteboard to you guys. So to make it visually, to teach you guys visually, I'll give it a border of solid, and by default it is black, so 2 pixels black, and you can visibly see our canvas inside our web page. Now this is supposed to represent our web page, so as we use the canvas tag, give it some height and width. Okay, let's see what happens if I make it 400. So it goes off the screen, so I'll just give it 300 height and a border of such. Now we are ready to draw things, or let's say shapes, inside our canvas by using JavaScript. Now I'll explain what happened. Although you might have already gotten the gist of it, the canvas tag creates a drawing surface inside our web page, and we give it an ID of my canvas so that we can target it easily later using JavaScript. Now the width and the height define the pixel resolution of our canvas. The width is 400 and 300 is the height. The border just helps us to see clearly on the page, so we have given it a border. And finally, we have also linked our JavaScript, which is linked by default inside this boilerplate, and we can style, or we can, let's say, start creating shapes inside our canvas using JavaScript. Now to draw, we need something called a context. The context is like your paintbrush. It provides you with all the drawing methods that you will need. So let's delete this default boilerplate, and let's select our canvas, shall we? So inside our canvas variable, we will use document dot get element by id and then inside our id tag we'll give my canvas. So get element by id my canvas. And after that we will create another variable called ctx, which will stand for context, and inside this we'll use a method called canvas dot get context. Now when we do 2D, this gives us the context of 2D. This gives us the 2D context and gives us methods to draw 2D shapes and lines and arcs and whatnot. So that is what we have done inside here. Now just to see if we have properly selected our canvas and selected our context as well, we will add a small check. So let's check our console, and it says canvas is ready to draw, so we have successfully selected it as well. So get element by id grabs our canvas, and get context 2D gives us the 2D rendering context of the canvas, which has methods like fill rectangle, stroke rectangle, which we'll be discussing in a while. Basically it gives us methods which allows us to draw things on the canvas in the 2D context. And we have also added a quick support check, and it is a good practice if you are using older browsers or environments. Now as for our shapes, let's draw a filled rectangle inside our canvas, which is the simplest possible shape. So after our check, we'll just do ctx dot fill style. We'll select a fill style at first, which is essentially the color that we'll be selecting. So royal blue, let's say. Now we have selected the color that we want to fill inside our rectangle, and we'll use by selecting the context variable. So ctx dot, now we'll use a method of the 2D context, which is fill rect. Now inside fill rect, we'll do first of all the coordinates of where we want to draw a rectangle. Now this is basically from the top of the canvas. So first of all, okay, let me write some boilerplate for you guys. So as a comment, if we do ctx dot fill rect, and inside it there are 4 parameters. So first of all, the x coordinate, and then the y coordinate, the width of the rectangle, and the height of the rectangle. So this x position is basically, it starts, the default position is 0 0, so it starts from the top left corner. And if we do suppose let's say 50 units of x and 50 units of y, it basically means that move 50 units right from the left side or top left corner of our canvas, and 50 units down from the top edge of our canvas. So it will be 50 units right, 50 units down. So that this is where our rectangle will be formed, around there basically. And as for our height and width, we'll do 150 and then 100. And as you can see, 50 units from the left and 50 units from the top, our rectangles has start to draw, or let's say a rectangle has been drawn or sketched on our canvas. Now this has a color of royal blue. We can even change the color to red. It defaults to black if we don't put any color, so we'll write red. And as you can see, the width is 150 and the height is 100. Now if we do 150 150, a square will be drawn. And this is basically how the fill rect method works. Now notice how you have to choose a fill style if you want to color our rectangle. Now what I encourage you guys to do is you can try out drawing this anywhere on or inside our canvas. Let's say 150 and 50, and see where our rectangle is drawn. You can change the position of your rectangles. You can draw many rectangles as you want. You can even draw a small square house using your rectangles. Let's say you can draw windows inside your rectangles and stuff like that. Now if you try changing the color or the position of the rectangle and see how it updates, that will help you to get used to the coordinates. Now what if I want to draw another type of a rectangle? So let's say I just want to draw a rectangle where the color inside is just the default background color, that is white, but it has a border color of red. Now instead of using fill rect, we can draw a rectangle using a method called stroke rect. So I'll comment this, and let's draw another rectangle. So we can just draw, so as I said before, we can also just draw the outline of a rectangle using a method called stroke rect. Now this method takes the same parameters as fill rect, just the drawing style is different. So instead of fill style, as you might have already guessed, in order to select the border color, we have to use ctx dot stroke style. So stroke style, and let's say we select it as red once again, and then we can also select the line width. Since we are drawing just the border, we can also select the width of the border. So let's say our line width is 3, and finally we can do ctx dot stroke rect, and we can enter the coordinates. So let's say I enter the same coordinates, that is 150 and then 50, and I actually draw a rectangle this time and not a square, so 150 and 100. Now you can see that just the border of the rectangle is drawn, and this is what stroke rect does. Now if I want to change the width of the line, I can just change this 1, 2, 3, and as you can see, the rectangle is being drawn like this. Now as I mentioned before, and you might have noticed already, both stroke rect and fill rect are methods of the canvas 2D rendering context. That is why we have selected it using get context and 2D, which we have defined as ctx. You can try changing the width and height, or use fill style equals to green to draw another shape next to it, or let's just say many shapes together. So if I uncomment this, of course it will be overlapped, but let's say I draw it really below, so 100. See, you can overlap shapes and create simple figurines of your own by combining many rectangles. And experimenting like this is the fastest way to understand how canvas coordinates work. And just a bonus tip to you guys, you don't exactly have to spell out colors when you use fill style and stroke style. If you have a hex code, you can just paste your hex code and it'll take that color instantly. So you can also paste hex code, and not only hex code, you can also put RGBA values. So if I do RGBA, and inside we can put, let's say I want it to be green, let's say, so 0, 255, and then 0 once again, and it has turned green. But wait, there is the alpha value as well. If you want to control the opacity of your shapes, you can put alpha values as much as you want. So if I do 0.5, you can see that it has semi-transparent, and if I do 0.1, it is really transparent, and if I do 0.8, it is not as much transparent. In fact, it is not noticeable to my eyes. So my point is that you can basically control the opacity of the shapes that you draw as well. And it doesn't only apply to fill style, it applies to stroke style as well. So if I paste the hex code, it takes the hex code's color, and if I use RGBA values, it's the same as I mentioned. So copy and then paste, so it takes the opacity as well. And that's about it. So with that being said, congratulations everyone, you just created your first shapes using HTML5 canvas. And now, since this was an introduction episode only, I would like to keep it short and sweet. So in the next episode, we'll learn how to draw more shapes like arcs. We'll understand how we can control the shapes of arcs and draw circles with them as well. And not only arcs and circles, we'll draw lines from one point to another as well on the canvas. So if you enjoyed this episode or found this episode helpful or insightful, hit that like button and subscribe for more such videos. And do turn on notifications so you don't miss the rest of the series. And until next time, bye bye and happy coding. Hey everyone, welcome back to the HTML5 Canvas for Beginners series. Now in the last episode, we set up our canvas and learned how to draw simple rectangles in different places. And in today's episode, we're taking it a step further. So I'll show you how to draw lines like this, circles and triangles, which will enable us to draw custom shapes like this pentagon right here and objects of our choice. And by the end of this video, you'll have created this little house right here. Or at least you'll be able to create this little house on your own with the knowledge that you gain. So without any further ado, let's get on with the video. Okay, to get started, I will head over to codin.com, and inside codin.com, I'll go over to their compiler as usual, and inside the languages, I'll pick web languages and HTML, CSS, and JavaScript. Now, In place of our default boilerplate which has an h1 tag, I will put a canvas tag so that we can start drawing inside our canvas. And inside our canvas tag, I'll put there an ID to select it in JavaScript, which will be my canvas. The height will be 300 and the width will be 400. And a quick note, just make sure your canvas has a width and height if you desire a certain width and height, either in HTML or CSS. I have done here in HTML. And if you don't set them, the default size is 300 by 150 pixels, which can sometimes confuse beginners. So to make our canvas visible, first of all, we will select it in CSS and give it a border. Okay, so this is our canvas right here, and now we'll be heading towards JavaScript. Now, as we said, we'll start with something simple, that is a line, drawing a straight line on the canvas. First, as we did in our previous video, we will select our canvas element and get a 2D rendering context in order to use the methods of the 2D rendering context. So first we'll do const canvas equals document dot get element by ID, and then the ID is my canvas. I'm pretty sure I put that. Okay, my canvas. And after that, we'll do for selecting the context, we'll do ctx equals canvas dot get context, and inside get context we'll do 2D. So this will give us the methods of the 2D rendering context, which we are going to be discussing today. Now, in order to draw or start drawing any shape at all except for, well, the rectangle like we did in the previous video, we have to use a method called begin path. Now it goes like ctx, I'll just type it out instead of commenting it. So ctx dot begin path. Now what this does is it tells the canvas that we are starting a new path. Begin path tells the canvas that we are starting to draw a new shape. So after begin path, after we have declared that we are drawing a new shape, we have to write ctx dot move to, and this will accept a pair of coordinates. For now, let's say it's 50 and 250 on the y coordinate. Well, this is the starting point of our line or any drawing that we will start to later on. First, this is our starting point. You can also see that ctx.move2 places our pen onto this coordinate right here. So we have placed our pen or pencil, whatever you want, on 50, that is 50 units from the left, and 250 units from the top. So we have started placing our pen right over here. Now in order to move our line from that point, this will be the starting point of our line, this will be the starting point of our line, and in order to determine the ending point of our line, we have to use a method called line to. It's like saying draw a line to. So suppose we are drawing a line to 100 and then 200, let's say. So this draws a line from starting point to this point right here, 100 and 200. So now in order to complete the stroke of our line, first of all we have to determine if we want, first of all we have to determine if we want to draw the line in any other color. So since drawing is called a stroke, we have to determine a stroke style. So let's say I want to draw a red line at first. So ctx.stroke style equals red, right? And after that, let's say I want the line to be a bit on the thicker side. So I'll say ctx.line width equals 3. Now finally, we have determined our starting point, which is move to, and our ending point, which is line to. Now in order to actually draw the line on our canvas, we have to write ctx.stroke. Sorry for my spelling, stroke. So you can see that a line has been drawn from our starting point onto our ending point. So you can think of it like sketching. You lift your pencil up, that is declared by begin path, where you decide to draw a new shape, and then you place it down onto a point, which is move to. You determine where the line will go to, that is line to, and finally you complete, or let's say actually draw the line with ctx.stroke. That is how drawing a line works. Okay, so that was how to draw a line. Now we will proceed with drawing a circle, and for that we use a method. Let me just comment this out. We will use a method called dot arc. Now, what is an arc? An arc is a part of a curve, especially which is the part of the circumference of a circle. So for drawing an arc too, we have to first declare that we are going to draw a new shape. And that's right, we have to first write ctx dot begin path, since we are starting with a new path. So ctx dot begin path, and after that we will use a method called ctx dot arc. And let me just explain to you what arguments does the method accept. So when we do ctx dot arc, it accepts a total of 6 arguments. First of all, it's obvious, the x and y position, but be careful, these are the position of the center. So this x and y coordinate is the coordinates of the center of the circle. So after our x and y coordinates, we have our radius of the circle or the arc, and then we have the starting angle and then the ending angle. And make sure to keep in mind that they are all in radians. They are not in degrees, so 30 degrees or stuff like that, you don't have to determine them in degrees. This starting angle and ending angle are in radians. And I'll explain the concept of radians in just a while after I explain the arguments. And after these 4 arguments, or let's say 5 arguments, the final argument is whether to spin the circle or the arc counterclockwise or not. So the default spinning of the arc is of clockwise. So if a line was like this, it would spin this way and form a circle. But if you write this counterclockwise argument as true, it will spin like this. And it will all be clear when I demonstrate later by drawing an arc or a circle. So let's start with drawing our circle. But before that, we have to keep in mind that a circle has an angle of 360 degrees. Now, for an easy conversion, since we are not using degrees and using radians, you have to keep in mind that 360 degrees is equal to 2 pi radians. Now, there's a video of Khan Academy that explains this concept of radians quite well. I'll link it down in the description below so that you can understand the concept of how radians work while measuring angles fully and easily. But for now, you have to just keep this in mind, that 360 degrees is equal to 2 pi radians. Now, however degrees you want to draw as an angle, you can just shift this on the right side or divide both sides by 360 degrees. So 1 degree is equal to pi by 180 radians. So the conversion is pretty easy, but for now we're going to be drawing only a circle, so 2 pi radians is enough to keep in mind. Now after that, let's actually use the method. So ctx dot arc. Now as for our center, we want it to be on 200 and 150, let's say. And after that, let's say it has a radius of 50. The starting angle will obviously be 0, since we are going full circle. The starting angle will be 0, it will start flat, and then for a full turn of 360 degrees which a circle has, as I explained before, it is 2 pi radians. Now how do we access the value of pi? We do it by doing math, sorry for the caps lock, math dot pi. Now this will give us the value of pi, and then for multiplying it by 2, we'll do multiply it by 2. Now, do we want it to go counterclockwise or not? Now, when you're actually drawing a full circle, it doesn't matter if it goes counterclockwise or clockwise, it still goes full circle and draws a complete circle. So it's okay if we leave out the argument. Now, we have determined the path of the circle. Now we want to determine if we want to fill the circle or not. So this is just explaining in canvas that we want a circle to be drawn at this part. We have not actually drawn a circle till now. Now to do that, let's first determine the fill style. Let's say I want the circle to be yellow. So if I want to fill the circle with a yellow color, I'll have to determine a fill style which will equal to yellow. And let's say we want to fill it we'll do ctx dot fill. Okay, I made a mistake right here. It should be fill. Since it is a method of the 2D rendering context, it will take a pair of parentheses. So we can see that we have a yellow circle which is filled with the yellow color, obviously, since we have determined a fill style and we have filled it. Now, in order to give it a border, let's say we want to give it a border and we want to give it a black border. So it will be ctx. It will default to black, so let's say the stroke style will be blue. So stroke style equals blue, and we'll do ctx dot stroke. So you can see that a blue border has appeared around our circle. And this is how you draw a circle. You determine the coordinates of its center. We have put it as 200 and 150. Let's do it 100, and we can see that the circle shifts. And we determine its radius, its starting angle, and then its turning angle, or let's say its ending angle. Now, this is what I mean by counterclockwise or clockwise. Now, let's say I wanted to just make an arc of 180 degrees. Now, since 360 degrees is equal to 2 pi radians, 180 degrees will equal to pi radians. So if we remove this, we can see that the 180 degrees is formed clockwise. Now, if I do it as false inside our counterclockwise argument, we can still see that it turns clockwise. Since it is obvious, we have turned counterclockwise to false. But if we turn this to true, so true, we can see that the semicircle or the 180 degrees arc starts rotating from the counterclockwise. So this value determines where you want or how you want your arc to be drawn. So while drawing a circle, obviously the even if I mention this as true, I want to spin it counterclockwise, it still is a full circle, so it doesn't matter that much. But when you want to draw arcs like that, whether or not you mention this argument does matter. So for now, I'll just remove it to show that it doesn't make any difference. Now we have successfully drawn a circle as well. We have drawn an arc, we have used the arc method, and we have used fill style to fill the circle and stroke style to give it a border. Now let's draw a triangle, shall we? Okay. Now I want to draw a triangle as well. So in order to draw a triangle, there is no built-in triangle method in Canvas. We simply connect 3 points as lines. So remember how we draw a line, how we drew a line from one point to another? We'll do just that in order to form a triangle. So once again, in order to start drawing a new shape, we have to begin a new path. So we'll do begin path. And after that, we'll choose a starting point. So ctx dot move to, this will select a starting point. This will be our first corner, so 150. Oh, I meant to type out 150. And let's say 200. Now, after that, this is our first corner, so first corner, let's see. After that, I'll do line 2. So line 2, 250, and then 200. So this will be our second corner. And after that, we'll do ctx dot line 2, and then for our top, we'll do 200 and then 120. So this will be our top corner. Okay, for some reason I'm not typing O's. Top corner. Okay. Now, I'll show you something right now. If I commit the line and draw the line as stroke right now, we can see that the triangle is not complete. Okay, I made the screen larger for you guys in order to see. Now you can see that if we commit our stroke by doing ctx.stroke, we'll see that the triangle is incomplete. Now, if we do ctx.line2 and then enter the coordinates of our beginning, so 150 and 200, this should be small o, you can see that it gets the job done. But there is a simpler method than doing this. Instead of mentioning the coordinates of our initial point and drawing a line to that initial point, we can just do ctx close path. and you can see that it just gets the job done, and it is way easier than mentioning the coordinates once again. So this connects it back to our first point, and that is how you draw a triangle. You mention 3 points and you connect the line back to your first point by using ctx.closePath. Now if you want to fill up this triangle, you can just do ctx.fillStyle equals, let's say we want to draw a purple triangle, and ctx.fill. Now you can see that the border is still a blue color. Well, that is because we have mentioned the stroke style as blue in our previous shape. Now if we explicitly mention the stroke style to be different, black, you can see that it will have a black border. Now let me comment this out so that you can see it properly. You can see that it has a black border, and you will notice that if I comment out this line right here and just do fill, it will take on the fill style of our previous shape, that is yellow. We have defined the fill style as yellow, and if we do ctx.fill, it will fill our triangle with yellow. So this means that if you want your shapes to be of any other color, you have to explicitly define them and color them. Otherwise, they'll take on the color or border color of your previous definitions with stroke style and fill style. Okay, now you have drawn a triangle, and not just a triangle. With the knowledge of drawing lines with line to, move to, and close path, you can draw any shape that you want, which has sides and corners. And just to show you, I have drawn a pentagon right here with a top right point and upper right point, lower right point, lower left point, and upper left point as well. And I have used a line to, line to, line to, line to, and to get back to our original point, I have used close path. And this is how you can draw custom shapes as well. Now, as for this house that I showed you in the beginning of the video, I encourage you to try it out on your own, since that is how you will learn. Now, in this code right here, I have made a function called drawHouse, where you only have to enter the x and y coordinates, and the base of the house is drawn first. That is, this rectangle is drawn first according to those coordinates, and all the other shapes, including this roof, this door right here, and this window, is drawn according to those coordinates by minus adding or subtracting values from the coordinates. So I encourage you to draw this house on your own. And just a heads up, whatever if suppose you want to place this rectangle on top of this rectangle, well, you have to write the code for this rectangle below the code of this rectangle. Suppose now I had drawn a triangle at this place before, so this is the triangle that I had drawn, and notice how this part of the code is above or earlier than this house part of the code. If I cut this and paste this code below, you'll see that the triangle appears above the house. So that is how it works. That is how layering works inside Canvas. Now with that knowledge, I hope you can draw the house just fine. And don't worry if you're not able to achieve this. I'll leave the source code down for this house and for this pretty sun in the description below. You can check it out if you run into any problems at all. And that was it for today's video, guys. Today you learned how to draw lines, circles, triangles, and custom shapes, and you hopefully have combined them onto your full project and try this out on your own in order to learn. Now in the next episode, we'll bring these drawings to life with colors, gradients, and shadows, so hope you don't miss it. If this episode helped you, if you found this video helpful or learned anything from the video at all, hope you drop a like, subscribe to the channel, and share it with someone that is learning frontend. Now, until the next time, until the next episode, bye bye and happy coding. Hello everybody and welcome back to the HTML5 Canvas for Beginners series. Now, so far in this series we have learned how to draw shapes and paths, and now we will be breathing life into them using colors, gradients, and even shadows. Now by the end of this video, you'll know how to paint this beautiful sunset onto your canvas. So without further ado, let's get started with the video. Now, I've kept the same setup of our last two episodes. I've head over to Coding.com's compiler and I have created a canvas of height 300 and width 400. I have put a border of solid 2 pixels on the canvas so it's visible, and I have also selected our canvas and stored it inside a variable called canvas. And after selecting our canvas, I have selected or gotten the context or 2D context inside the variable called ctx. Now let's get started with our gradients. Now, gradients make shapes look richer and more dynamic. So let's start with a linear gradient, one that transitions smoothly from one color to another through a side. So first, let's create a variable called linear gradient, and inside this we will use a method called dot create linear gradient. Now this method takes 4 arguments and they are x0, y0, x1 and y1. So x0, y0 is basically the coordinates, or they are the coordinates of the starting point of the gradient where a gradient should start, and these are the coordinates of the ending point of the gradient. Now we will be using this method and store it inside linear gradient. So we'll use ctx, which is our 2D context of our canvas, dot create linear gradient. Now inside this we will select a coordinate of starting coordinate of, let's say, 50 and then 200. So 50 and 200. Now let's say I want the gradient to go from the left side to the right side. So suppose we have selected 50 and then 200. Now we'll still select 200, but we'll select a different x coordinate. So let's say 200 and 200. Now since the x values are different but the y values are the same, the gradient will be horizontal. Now after that we will use something called add color stop. Now this method is to put different colors inside the set length of your gradient. So in here basically I've told canvas that I want to put a gradient from this point, let's say 50 and 200, all the way from here to 200 pixels right, since I have increased the value of x by 150. So let's say 150 pixels right at the position of 200. I want the gradient to go from here to here. So in between that path, this method allows us to add many colors. So the first argument that this method will take is the position of the colors from 0 to 1. Now if this is confusing to you right now, after we do it practically you'll understand it. And after that, after the position that you want to put the color at, you can enter the color that you want to put. So we have color. Now let's use this for our linear gradient. So by selecting our linear gradient, so linear gradient dot add color stop. Now let's say at first I want it to start from 0. That is the starting position of our gradient, and let's say I want the gradient to be light blue. So light blue, the B should be small actually. And after that, let's say towards the end I want the gradient to look blue. So I'll say if I want to put this color towards the end, I'll type out 1 and it will go as blue. Now we have determined a gradient and set its path already, and also have determined what colors that the gradient should contain. Now in order to actually fill those gradient colors into a shape, we have to first select a fill style. So ctx.fillStyle, and this will equal to our linear gradient variable, since we want the color to be linear gradient. So linear gradient. Now for that I'll use ctx.fillRect to form a rectangle with the gradient inside it. Now notice that we have started from 50 and 200, so we'll start our rectangle from that point as well. So 50 and 200, these are the starting coordinates of our rectangle, and let's say the width is 150 and the height is 100. So you can see that, okay, let's shift this towards the upper side. So let's say 100, and this will be 100 as well, and our rectangle will be at 100. So okay, that's better. Now you can see that it starts from a shade of light blue and it moves towards the shade of blue. So it blends in the gradient nicely. Now what I was meaning with color stops is, suppose I want to add a green color in between as well. So let's say I want to do linear gradient dot add color stop, and okay, after that let's say I want blue to be in the middle and end to have a green color. So 0.4 blue, and then 1, let's say I want it to be green. Now you can see what I mean. So let's say I want the green to appear a bit earlier, so I can set the position of that green color to 0.8, and voila, it appears a bit earlier. And this is what I mean by adding our color stops. Now keep in mind that we are using a linear gradient horizontally. If you want to use the linear gradient vertically, you will have to change the values of your coordinates. So if you want the gradient to go from top to bottom, you'll have to keep the x values the same, but y values will be different. So let's say I want the x values to remain the same. The x values will be 50, but the y values will, so let's say this is 50, and the y values will differ like this. So this is basically saying that I want the gradient to go from 50 and 100 to 50 and 200. So see how I direct the gradient from this point to this point by using coordinate values. Now of course this might sound confusing at first, but I do encourage you to try this on your own and see how the gradient behaves according to changed coordinate values. And keep in mind that this rectangle should be placed according to the coordinates of your gradient and vice versa. So if you draw a rectangle here, the coordinates of the gradient should be corresponding to that rectangle's coordinates and vice versa. So I hope you properly understand the concept of the linear gradient. In order to use the linear gradient, you have to have a starting point and the ending point. In order to use a linear gradient, you have to have a starting point, which is 50 and 100, and an ending point, which is 50 and 200. So the gradient goes from here to here. So you always have to tell Canvas from where you want the gradient to start and where you want the gradient to end, and it will draw the gradient respectfully. So that is how you use a linear gradient. Now after talking about linear gradients, let's talk about radial gradients. Radial gradients work the same way, but they radiate outwards in a circular pattern, which are perfect for glowing effects like the sun or some lights. Now for creating radial gradients, we use the method called create radial gradient, and it takes the following arguments: x0, y0, r0, and x1, y1, and r1. Now, in a radial gradient, you define two circles, one where the gradient starts, which is this circle, and another where the gradient ends, so this circle. Now, the coordinates x0, y0, and x1, y1 represent the centers of those circles, and r0 and r1 represent their radii. Now, in most cases, both the circles share the same center, as you can see in this method that we have used, ctx.createRadialGradient, 190, 150, and 190 and 150. The only thing that differs is the radii. Since this defines where the gradient starts, it starts 10 units away from the center of both circles, so the gradient is starting here, and it ends towards 60 units. As you can see that the gradient ends toward here, and the red color shines at the end. So in this case as well, both the circles share the same center, and only the radii are different, which differentiates the inner circle and the outer circle and creates that smooth circular blend effect. Now let's see what we have done here. We have used the create radial gradient method, in which we have defined two circles which share the same center but their radiuses are different, and after that we have added color stops in this as well. So in this case too, if I wanted to have, well, three colors, let's say 0.4 and then 0.8. Now let's say this was green. So you can see that in this radial gradient as well, add color stop achieves the same thing. It places colors in between the path of your gradient. So first we have yellow, so yellow at 0, and at 0.4 we have red, and at 0.8 we have green. So that is how add color stop works in this case as well inside our radial gradient. So in order to actually apply the gradient, we have used ctx.fillStyle, and inside our fill style we have put our radial gradient. And if you have watched the previous episode of drawing shapes, you might know how to draw a circle. We first use ctx.beginPath to tell Canvas that we are going to draw a new shape, and we use the ctx.arc method. These are the coordinates of the center of the circle or of the arc. This is the radius, and this is the starting angle and the ending angle, which are both in radians. If you have missed the previous episode and don't know how to draw circles or other shapes, I recommend you watch it. The link will be in the description. And you might have noticed that the coordinates of the center of the circle and the radius correspond to the values of that of the ending circle of our gradient. And that is essential if you want to apply the whole gradient towards the circle.
Okay, now we know about making radial gradients, why don't we move over to shadows? Shadows make objects look more 3D and grounded. But remember, once you set a shadow, it affects every shape that you draw afterwards, so that is why we have to use some special methods. But before that, let's draw a rectangle on our canvas. So first of all, we'll select a fill style, which will be lime green. And after that, we will use our fill rect method. So fill rect, let's say we want to start our rectangle at 100 and 150, and let's say we want it to be of 150 pixels of width and 80 of height. Now this is our rectangle right here. Now if I wanted to add a shadow to this, I would have to add some properties before our rectangle. So first of all, we should do ctx.save. Now what this will do is it will save the state of our code from before. So suppose we have selected a few fill styles or stroke styles or line widths, it will save all of those properties onto our save. And after we draw our shadow, which is only for a single object, so this is a temporary shadow, we don't want to add shadows to all of our objects. Suppose we want to add a shadow to this rectangle only. So after we are done with our shadow, we can do ctx.restore to restore our values, and I'll demonstrate that in just a while. But before that, let's add some shadows to our rectangle right here. Now in order to add a shadow, you have to first of all select a shadow color. So we'll go ctx.shadowColor equals, we'll use an RGBA value. So let's say we want a gray shadow, and for that I'll do 0 0 0 in all of the RGB, and as for our alpha value, we'll use 0.5. and after that we'll have to select a shadow blur. Now this is how transparent or how dense you want or how blurry you want your shadow to be. So for now I'll just do 15 since we can't see its effect anyways. And after this, now in order to control how far the shadow is moved from our shape right here, or let's say how the shadow is positioned according to our shape or with reference to our shape, we will use something called shadow offsets. So ctx dot shadow offset x, so this will control the x position of our shadow, let's say 10, and ctx dot shadow offset offset set y, this will control the y position of our shadow. We'll do 10 here as well. Oh, there's no shadow since I forgot to mention dot over here. So you can see that our rectangle has a beautiful shadow. And what I mean by shadow offset x and shadow offset y is, for now it's 10. But if we want our shadow to be further to the right, we can increase the value of shadow offset x and make it, let's say, 20. Now you can see that it is further to the right, and in order to show a large difference, I'll do 90. So you can see that our shadow is way over to the right. It has been shifted to right, and if we want to move our shadow further bit down, we can do the same with our shadow offset y. Now these are for positive values, but let's say I want our shadow to appear upwards. Let's say our light source is right here and the shadow should appear upwards, so I'll do -40. That will move it upwards, and same for the x value. If I do -90, it will move on to the left. So that is how you can control your shadow. And what I mean by shadow blur is, if I put shadow blur 1, it just seems that if there is a gray rectangle beside our original rectangle, so you can control how dense your shadow is. So if I put on 50, it will look really blurry, and if I put on 100, it will look like there's not a shadow at all. So there's only a gray shade here. So I feel like 15 is a nice value to show a blurry shadow of our rectangle. And that is how you use shadows in Canvas. Now what I mean by using ctx.save and ctx.restore is, suppose I just wanted to add a shadow to our green rectangle right here, but if we draw a if we draw a circle right after our rectangle, you can see that our shadow is applied to the circle as well. So in order to not apply our shadow to this gradient circle, we'll just cut this out, use ctx.restore after ctx.save before applying our shadow to our rectangle, and we'll move it after we use ctx.restore. And after that, you can see that none of the shadows are applied to this circle right here. And that is why you should use ctx.save and ctx.restore when you are using shadows, since you would want to apply a shadow to a single object only. Now, it's a different story if you want to apply shadows to all of the objects present in the scene. If that's the case, you don't have to use this, and you can just move this inside the restore. So you can push this inside, or let's say between ctx.save and ctx.restore. But normally you would do this. And that is all about shadows. Now, as for our beautiful mini project right here, our painting of the evening sky with the sun setting above the ocean, we have used a linear gradient for the sky, or let's say the evening sky, a radial gradient for our sun, and a linear gradient for the reflection of our sun onto our ocean as well. Now, as with our previous episodes, I'll only explain some bits of the code, but I want you guys to explore and try to make this on your own. And of course, as always, I'll leave this link down in the description for you guys to check it out, for you guys to correct yourselves or just learn from it. Now, as I mentioned, for our sky, we have used a linear gradient of orange to deep purple to simulate that evening sky. We have created a linear gradient from 0, 0, the starting point to the height of our canvas. So, and after that we have added a color stop of our orange and our purple, and after that we have used the fill style and finally filled our rectangle. And the size of the rectangle is the canvas width and the canvas height, so basically in the entire canvas. For our sun, as I mentioned before, we have used a linear gradient on a circle from yellow to orange. And as for our ocean, we have just made a rectangle with the ocean color, and above that rectangle is a linear gradient to simulate that reflection. So this is basically a white linear gradient with some bit of opacity. And after that, we have wrapped all of these gradients inside functions as draw sky, draw sun, and draw ocean. And at last, we have used those functions. So I want you guys to not rely on tutorials and basically explore your way to making paintings like these, and that is how you will learn. So if you like the video helpful, please drop a like and subscribe to our channel for more such videos. And in the next episode, we'll learn how to add text to the canvas, style it, and even make it look 3D. So until then, bye bye and happy coding. Hey everybody, welcome back to the HTML5 Canvas for Beginners series. Now in this series, we have been taking things slow and covering one thing at a time. In the last episode of our series, we learned how to create gradients inside our canvas and also how to work with shadows. And in today's episode, we'll be working with simple text on our HTML5 canvas. In this episode, you'll learn how to draw and style text inside the canvas, align it perfectly using alignment, and adding shadows and also gradients to your text. And in the end, you'll be able to make this simple yet nice banner right here. So that being said, let's dive right in. Now, when wanting to write text onto our canvas, Canvas provides us with two main methods, and they are fill text and stroke text. First of all, fill text is used for drawing solid text onto our canvas, whereas stroke text is used for drawing outline text like this. And for styling the text that we draw onto our canvas using these two methods, we have styling properties. And they include, first of all, ctx.font, which is the main styling method that we use for our text. As you can see, it controls our variant, our font weight, which is bold, and our font size, 30 pixel, and our font family as well. Next up, we have ctx.fillstyle, which is used for coloring the text that we draw onto our canvas. Next up, for aligning the text onto our canvas properly, we have two main properties, and they are ctx.textalign,
which is used for horizontal alignment, and ctx.baseline, which is used for vertical alignment. Now, I'll explain these styling methods later on in the video with code so that it's clear and the result is right there on your screen as well. So before we start with styling our text, let's simply draw the text onto our canvas with the before mentioned two methods, which are fill text and stroke text. Okay, so we are back here in our compiler. Once again, I have used a boilerplate code already. Here is our canvas element with the ID myCanvas, height 300 and width 400. I styled its border to be solid 2 pixels, and I have selected the canvas by document.getElementById and have gotten the 2D rendering context as well. Basic stuff that we have been doing since our previous videos, past 3 videos, let's say. Now, in order to draw a single line filled text, you need to use the .fillText method, which takes the following arguments. So first I'll do ctx.fillText. First you want to enter the text that you want to fill. So let's say I want to first say hello canvas, and after that the coordinates of where the text you want to be. So let's say I want it to start at 30 and 50. By default, this value is the starting point of your text, and you can see hello canvas appears onto our canvas. And as for our stroke text, we'll do ctx. First we'll select the line width for our stroke, so line width, let's say it's 2, and once again we'll do stroke text this time. Now this also accepts the same arguments as fill text, which is the text you want to print. So let's say draw hello canvas once again, and the coordinates. So let's say we want it to be 30 and 80. Okay, here you might feel like the text is too small and the outline text just seems bold. It doesn't even seem outlined. And that is because by default, when you don't mention a text size, or let's say font size, Canvas uses a 10 pixel sans serif font. So the differences aren't clear enough. Now, when we use a ctx.font property to style the text and use fill style to give the text some color, the differences can be seen. So first of all, before using our ctx.fillText, we will select a font. So ctx.font equals 24 pixels and then an Arial, let's say. Okay, now you can see that hello canvas is visible properly, and you know the outline text is still not that clear, so why don't we increase its size some more. So you can see that if I do 54, let's make it 100, you can see the difference between the fill text and stroke text. As I said earlier, this is for solid text and this is for outline text. So hope that is clear enough for you guys. Now if I want to color our text, we can use fill style simply. So if I do ctx.fillstyle equals, let's say, red, you can see it has a red fill style. And if I want to color the outline, I should just do the same but with stroke style. So ctx.strokestyle equals red. So you can see I have colored our text as well. Now you have to keep in mind that each fill text and each stroke text only draws a single line. It doesn't wrap automatically if the text is oversized beyond the canvas. So let's say I make it 84 pixels. You can see that it doesn't wrap around and the rest of the text doesn't appear below our main text. It just vanishes. So do keep in mind that this fill text and stroke text only draws a single line. Now this is basically the mandatory styling that you should do if you are to use ctx.font, and that is your font size plus your font family. And apart from that, you can use the same font shorthand syntax as CSS, including weight, style, and fallback fonts. So if I wanted to style this a bit differently, let's say I want this to be blue, and let's say this is our style text, so styled text. And after that, we will make this first of all bold and italic. And this is too big, so first of all let's do 30 pixels, let's say 34 pixels. And as a fallback font, why don't we use sans serif? So this is how you can do styling with ctx.font. Now there are some other properties that you can mention instead of bold. You can even mention the font weight from 100 to 900 and other stuff as well, which you can basically just check out when you feel the need for it. For now, this much is enough. Now, after we have discussed styling our text up to a certain extent, let's move on to aligning our text onto our canvas. Now, aligning the text according to your wish or centering the text properly uses two properties, and they are text align, which controls the horizontal positioning of your text, and text baseline, which controls the vertical positioning. And in order to visualize this, I have drawn a simple grid onto our canvas with the help of our lines. So from our top middle to our bottom middle, I have drawn a line, and from our left middle to right middle, I have drawn another line. And this is the center of our canvas. Now, in order to draw centered text, so centered text, we have to use ctx.textalign equals center and ctx.textBaseline equals center as well. Now let's select our font, ctx.font. Let's say it's 32 pixels and Arial. And after that, our fill style, let's say we just make it black for now. Now, after selecting our font and after aligning our text onto center from both horizontal and vertical ways, let's finally use fill text. So let's say we print out centered. And we do it at the position of canvas dot width by 2, that is right at the dead center of our horizontal position, and our canvas dot height by 2. Oh, I'm sorry, this should be middle. Okay, now this makes sense. Now if I hadn't used text align, our centered text would start from this point. So if I comment this out, you can see that from canvas width by 2 and height by 2, that is this point right here, our text starts to draw. But if we use text align center, it is perfectly centered. And same goes with text baseline. If we omit text baseline, our text's bottom part is touching the middle, or let's say the Y position, that is height by 2. And if we type out middle, it starts from the middle. Now, apart from centering our text horizontally and vertically, we can do other things as well. If you want your text to end on the point that you specify, you can just type out end, and it will end at that point. If you type out start, it will start at that point, which is basically enabled by default. If we comment this out, it's the same. So start is the same, but if you want the text to end at the point that you specify, that is these coordinates right here, you can do end. And same goes for our baseline. If you want the top part of our text to touch the mentioned point vertically, you can type out top, and it will be like this. So let me put this in the center. And if we do bottom, the bottom part of our text box will touch our coordinate, not the actual text. If you want the actual text to touch the bottom line, like we do with our alphabetical characters, there are two ways. First of all, you can just mention alphabetical, and it will be like this, or you can just not mention text baseline at all. It will still be the same. So that is how you align your text on canvas. Now let's talk about a bonus part, shall we? If you ever need to know how much space your text is going to take up, there's a method to do that as well. And that method is using dot measure text. And that is a slightly advanced layout trick that we will use later when we build UI elements, but for now I will show you guys a simple demo. So first let's determine our font. ctx.font equals, let's say 28 pixels, and it's still Arial. So Arial. And after that, let's say I type out a message. So const message equals, our score is, let's say 1200. Now after that, if I want to find out the width of this text right here that we will be displaying on our canvas, we can just do const assign a variable, so matrix equals ctx.measureText, and inside that we'll measure our message text, which is like right this. So after that, in order to know its width, we'll do text width This is just a variable, and to find out its width, we can just do matrix dot width. Now this will give us the width. Now just to see how much the width is of that text, let's do console.log text width to output it onto our console. Now you can see that it's 143.21 pixels. So let's say I wanted to place the text right at the top right corner of my canvas and wanted to place it perfectly on the edge. Now since it is 143.21 pixels wide, I can just leave that amount of space and do ctx dot fill text, and we'll fill our message. And for our width, or let's say for our starting coordinate, we'll just do canvas dot width minus 143, how much was it? 143.21. And as for our height, let's say 30. So you can see that it's right at the edge, and you can calculate how much space it will take, or let's say how much space you have to leave from the very right end. So in situations like these, measuring the text width can come in handy. Okay, so that was about measuring the width of our text. Now let's give it some depth by adding shadows. So shadows instantly make the text pop, and just remember that once set, they affect everything. That is, once you set a shadow, you apply a shadow to everything. So it's good practice to wrap them around what's called a save and restore pair. So first of all, I'll do ctx.save to save the state of our program, and then after that I'll start to apply some shadow. Now, I've explained the process of applying the shadow in our previous video as well. If you haven't checked it out, link is in the description. That will be more clear. But for now, I'll just explain it simply. So, in order to determine a shadow color, we'll just do shadow color, and we'll just pick a light gray. So, RGBA values will be 000, comma 000, and then after that, it will be 0.35 for that transparency. Now, after our shadow color, we have to select what's called a shadow blur. Now this is the intensity of how blurry you want the shadow to be. So in our case, let's say I just want it to be 5. And oh, I meant to type 5. It will be apparent later in the video where we can actually see the result. Now after determining our shadow blur, we have to select how far we want the shadow to occur from our actual text. So that is done by ctx.shadow offset x. This will determine how far right or how far left our shadow will be. If I type out a positive value, it will be right, and if I type out a negative value, it will be left. And same with the vertical positioning. I want to type out shadow offset, and instead of x, I want to type out y. Now this will determine how far down or how far up our shadow will be. If positive value, it will be down. If negative, it will be up. Now, as for our font, we'll, let's say, select a 36 pixel font, but it will still be Arial. After that, let's align it on the center, text align, center. After that, ctx.text baseline equals middle. And after that, let's say it will be lime green, so ctx.fillStyle equals lime green. And then finally we'll use ctx.fillText, and we'll start to fill it at, let's say it will be shadow text to signify that it is shadow text, and it will be at canvas.width by 2. It will be at the center of the screen basically, and let's say it will be, the y coordinate will be canvas.height by 2. Okay, I see the problem. I found out the problem. This should be comma. That is why the shadow is not occurring. So you can see that our text has some shadow. Now what I mean by save, and okay, let's do restore as well, ctx.restore. Now you'll see that if I don't do ctx.restore, let's move this text over here below. So let's say I comment out ctx.restore, and if I print this, you'll be able to see that this has a shadow as well. Now if I do ctx.restore, you can see that it is in its original fill style, that is black, and it doesn't have a shadow. So in order to just apply a shadow to a single text, you have to wrap it between ctx.save and ctx.restore. And I hope that is clear for you guys. Now as for our gradients, let me remove all of this and start from scratch. Okay, I want to remove this as well. Now, as you know, with gradients, we have to use create linear gradients and create radial gradients. For this episode, we'll just be using ctx.create linear gradient. Now, to create a gradient, first we have to create a gradient variable and use our method. So ctx.create linear gradient. And remember what arguments this variable takes. It takes a starting point and an ending point. So it takes x1, y1, and x2, y2. So we have to fill this position in order to determine the direction of the gradient. So in order to determine the direction of the gradient, first we have to know where we are going to place our text. So I'll leave it at this for now. And okay, let's say I'll comment this for now. Now let's first create our text and place it somewhere. So ctx.font equals, let's say we want to keep it bold. So bold and 48 pixels and Arial. Now for aligning our text, we'll keep ctx.textAlign equals center, and after that we'll align it vertically as well. So text baseline equals middle, and let's say we want to fill the text at the dead center of our screen. So fill text, once again let's say it's gradient, and it is by canvas.width by 2, and let's say it's canvas.height by 2 as well. Now you can see that there's a bold text called gradient on the center of our screen, and that is because we have aligned it at the center of our screen. Now in order to put a gradient, we have to first put in these coordinates. This coordinate right here, our starting point, and this coordinate right here, our ending point. And for that, we have to put its coordinates, as I said. So as for our starting coordinate, this is the center of the screen, canvas.width by 2. And since it is placed at the center, our starting position is actually at this width's half. So it's canvas.width by 4. So it will be canvas. Oh, let me first uncomment this. It will be canvas.width by 4. And the height is the same, so we'll do canvas.width by 2. Now as for the ending position, keep in mind that the ending position is 3/4 of our whole width, since it is the second part of our halved width and it is in the middle of that as well. So I don't know how to explain the coordinates properly. I just know that it is, since this is 1 by 2, this is 3/4. This is half and this is 3/4. So okay, the ending point will be canvas.width times 3 by 4, and the y coordinate will be the same since we are going to apply a gradient horizontally. So the y coordinate will be the same, it is width by 2. Now we have already determined the path of our gradient. It will go from this point to this point. Now that's only left is to add the colors that will be present in the gradient and to fill the text with the gradient. So first we will use grad.addColorStop to add our first color, which will be at the position of 0 since it is the starting color, and it will be a pinkish red. So the hash values for that are FF 6B 6B, and after that we'll add our second color. So grad.addColorStop, and this will be the ending color. Okay, there shouldn't be space here, and this will be the ending color, so it will be 1, the position will be 1, and this will be a shade of violet. So C738 and D8. Now we have added color stops as well. All that is left is to fill the gradient. So before we use fill text, we'll add a fill style, and this will be our gradient, and voila, that is our gradient. It goes from a pinkish red to purple. Now do keep in mind that when applying gradients, you have to first determine where your text is placed, and that way you'll be able to determine from where the gradient will start, as I have done here, canvas.width by 4 and canvas.width by 2, that is this coordinate right here, and where the gradient will end, that is this coordinate right here. And that is how you apply gradients to text. It is like shapes. Whatever you can do to shapes, you can do to text as well, as for styling. Now, if you apply gradients like this, it gives your text a premium logo-like feel. And you can also experiment with the radial gradients as well. You can do a circular gradient as well. Now, as for our mini project right here, up until this point, you might already know what's going on in this code. First of all, we have given our canvas a background gradient of a kind of shades of blue. And after that, we have set a shadow color or shadow blur effect on our main code. Then we have filled the text onto the middle of the screen and aligned it with center and middle of text align and base align respectively. And after that, we have also applied not only fill text in our code but also stroke text for an outline to give our code that sharp look. And after that, we have also reset the shadow color to transparent, and then we have put down anonymous dev at the center of the screen as well. And that is what's going on in this code, or let's say mini project. I hope you try this on your own, and of course, like every video, I'll be leaving the source code down in the description if you want to check it out or edit this on your own. And that was it for this video. In the next video, we're going to be talking about using images on canvas, so make sure you tune in for that. And if you like this video or found this video helpful, do drop a like and subscribe to our channel for more such videos and hit that bell icon to get notified. Now, until the next time, bye bye and happy coding. Hey everyone, welcome back to the HTML5 Canvas for Beginners series. In the last episode, we discussed about working with text on the canvas, where we had this mini project of printing out, or let's say drawing out this code onto our canvas. And in today's episode, we're taking another step forward with how to draw images onto the canvas. Today, we'll cover how to load them properly, scale and crop them, position them exactly where we want, and even set background images like this. And in the end, we'll also do a mini practice project where we'll place a character like our Mario on top of a background image, like setting up a small game scene. So grab your code editor and let's get started. So since we are going to be working with images on this episode and not just shapes or text on our canvas, I am not going to be using our online compiler. Instead, I'm going to be using VS Code and a folder right here where I have set up two files, which are index.html and script.js, and 3 images as well. One is the background that we are going to be setting up onto our canvas, and another is a PNG image of 8-bit Mario, which is going to be our character for this episode, and another is a sprite sheet, which I have actually obtained from itch.io, and shout out to Ordinary Bumblebee, the creator of this sprite sheet, and credits to them as well. I'll be leaving the link for this down in the description. Now, let's get on with the video. Okay, so once you have your folder with your required images, you can just head over to this location right here and type out cmd and type out code space dot. What this will do is this will open your folder up in VS Code, and as you can see here, I have already typed out some boilerplate with some basic styling, where I have given the canvas a border of solid 2 pixels and display block and margin of 20 pixels. And I have also created a canvas element which has a width of 600 and height of 400, and given it an ID of game canvas so that we can select it later up in JavaScript and get the 2D rendering context from canvas.getContext2D. After that, you can just head over to go live and see how your canvas looks on the web page. So this is our canvas right here. Now in JavaScript, let's learn how to actually place an image on our canvas by using the .drawImage method. And before drawing, we need to ensure that the image is completely loaded, otherwise nothing will appear. And in order to do that, we have a method called img. Okay, I'm going to type out img only .onLoad, and what this will do is it will tell what to do when the image has finished loading. So once the image has finished loading, we have to actually draw the image onto our canvas. So we should type out ctx.drawImage. And draw image actually takes 3 parameters as default. It has many parameters, but the basic or let's say the easiest one is 3 parameters or arguments. So it takes on the image that you want to actually draw, so img, and then the place that you want to draw it at, or let's say the coordinates that you want the image to be drawn at, which is 50 and 50, let's say. So these are the arguments that the draw image will take. Now for this to work, we actually have to create an image objects, which we'll do by assigning it a variable. So const img equals new image. This will create an image object, and to actually give that image a source, we have to type out img.src equals then the location or the path of your image. So dot slash character dot png, since I have this image in the same folder, and you can see that Mayo is drawn onto the canvas instantly. Now you have to keep in mind that images load asynchronously, meaning that the browser might still be fetching, or let's say trying to fetch them while your script is running. So always you should use on load to ensure that your image actually loads before you draw that image. Now you can see that Mayo is a bit disproportionate. It is quite large and its feet are kind of cut off since the canvas is not too big, and that is where scaling images comes in. What if your image looks too big or too small? In our case, it is too big. So there's an easy fix for this, where draw image can scale it for you by adding width and height parameters. So instead of just let's say dot draw image, instead of just the image and coordinate, or let's say x and y, we can actually add more parameters, which are the width of the image and the height of the image, and this will scale the image for you. So if I want Mayo to be a compact size of 100 pixels and 100 pixels, you can see that it is scaled. And you can make it 150 by 150 as well, 150 and 150. So you can see that it is scaled a bit better, and you can of course fix its aspect ratio by manual hidden trial. So let's say I want to put its height as 200. You can see that it looks a bit normal. But if you don't want to do this manually and you want to maintain the image's original aspect ratio, you can calculate the height dynamically. So if I type out here const, or let's say once the image has finished loading, const aspect equals img.height by img.width. This will calculate the aspect ratio, and you can put the same size, so 150 150 without any worries, and just multiply the height with our aspect variable, and this will fix the aspect ratio for you guys. So if I do 100 by 100, it will fix the image and it won't look disproportionate at all. So that is how you scale images on the canvas. And I do hope you know what these values mean. These are the coordinates. This controls the x coordinates, so it should move right, and this controls the y coordinates, so it should move down as we increase it. So that was it about drawing images and actually scaling them onto your canvas. Now this is where things get a bit interesting. If you are working with sprite sheets, which are images which contain multiple images of a character either walking or their animation, you can draw specific parts of that image using an extended version of the dot draw image method, and I'll teach you how. So instead of just draw image, first of all let's create a new variable called const sprite equals new image, and sprite dot src will equal to, what did I save its name as? So sprite dot slash sprite dot png. Now if I want to draw our sprite, you can see that it draws the full image at first. So okay, if I do 300, okay, I didn't mean to do that, 300. So you can see that all of the images are drawn at once. But if you want to draw a certain part of the image at first, here are what ctx.drawImage accepts. So dot draw image, okay, I have this here. Instead of just width and height, it accepts first of all sx and sy. You can think of this as sprite X and sprite Y. This is where to start cropping the image from of the sprite. So it's the position where the image starts cropping off the sprite sheet. And after SX and SY, we have SW and SH. So these are the width and height of the cropped area. So we start from here. This much is the width, this much is the height. So those are these values right here. And after that, where to place it on the canvas. So that is dx and dy. And after that, finally, we have how large you want it drawn on the canvas. So the actual scale of the image. So dw and dh. So if we follow that same aspect right here, let's do it like this. We'll start to crop it from the top left, and that is the starting position of the image. So 0 and 0. And since our sprite sheet is, okay, it looks really nice right now, but we have to draw a single character. Since our sprite sheet is about 30 pixels wide and 50 pixels of height, I'll do 30 and 50. Okay, this is how much I want the cropped area to be of the image. Now to position it on the canvas, I'll enter the coordinates, which are 200 and 50. Now after that, I have how to scale the image. So let's say it's 30 and 50 as well. So you can see that we have our character right here, and let's increase its size by a factor of 50. So I have 80 and then 100. So you can see that we have a cropped image of our sprite sheet. And that is how you crop images. Okay, these values shouldn't be here. So think of these two values as where you want to start cutting from. These two values as how much you want to cut or how big the piece is of the image. So let's say I start from here, 0, 0. It's 30 and 50. Those are the coordinates right here. SW and SH, and DX and DY are where you want the image to be placed on the canvas, and DW and DH are the scale of the image of how you want to size the cut piece of the image. So that is how you cut a sprite sheet, or let's say crop images or sprites in Canvas. Now it is perfect for games when you need different poses or frames from the same image sprite sheet like this. And after talking about cropping images inside Canvas, let's talk about setting background images. Sometimes you want to use an image as a background that fills the whole canvas, and that is super easy as well. First of all, you have to bring up, okay, let's comment all of this. Now, first of all, you have to bring up the background image. Okay, first we need to create a background variable and make it an image object, so new image. And after that, we have bg.src. We want to fill its source. So it is ./background.jpg in my case. So it is background.jpg. And after that, in order to actually fill the background onto the canvas, we have to first execute our onload function. So bg.onload. When the background loads, we want to fill the canvas. So we'll do ctx.drawImage, and then we want the image to be the background. We'll start from 0, 0, that is the top left position of this canvas right here, and you can see that it is fit perfectly. Well, not perfectly, it has just filled the canvas right now, but if we scale it to canvas.width and canvas.height, you can see that it fits perfectly inside our canvas. So when we start from 0, 0, that is the top left corner, or let's say the starting position of the canvas, and set the image's height and width equal to the canvas, we get this beautiful image. It covers the whole canvas and becomes the background image. And this method is perfect for backdrops, game maps, or wallpapers as well. Okay, now that we have drawn our background as well, let's try to draw our character on top of this beautiful background right here. So for now, I'll uncomment this. I'll place this below. So after that, I'll use img.src. Okay, both of these I'll place below our background since I want the background to load at first. Okay, first we'll load our background and then we'll load our image. And inside that, first we want to make sure that the background is finished loading and the background is drawn onto the canvas at first. And then on top of that, we want to draw the character. So inside bg.onload, after we draw our background onto the canvas, we'll do img.onload. And inside this, we'll place an arrow function which will actually draw our character onto the canvas. So draw image, and we'll do img, and then let's say 250 and then 50. You can see that our character is placed on top of the background. Let's scale this properly. Let's also remove this aspect ratio and then put it inside our onload. And let's multiply our Mario by the aspect ratio as well. Aspect. So you can see it pretty clearly. Let's place him on the mountains. So 100. Okay. You can see that we have drawn our character on top of our background, and it was pretty easy. You just have to make sure that you load your background first, and if you load your image, or let's say your character at first, this could happen. Your character could not draw at all. Since the character first finishes loading and then the background, so the background is drawn on top of the character, and you don't want that. So first you have to place your background, load your background, and then only your character. Okay, I'm repeating the same phrase again and again, but you get the gist. And that was it for today. You just learned how to load, draw, scale, crop, and even layer images on top of each other inside HTML5 canvas. And in the next episode, we'll be dealing with animations inside HTML5 canvas, which is an interesting topic, so do tune in for that. If you liked the video or found the video helpful, please do drop a like and subscribe to our channel for more such videos. And until the next time, bye bye and happy coding. Hey everyone, welcome back to the HTML5 Canvas for Beginners series. Now in the last episode, we learned how to work with images on the canvas, where we drew characters on the screen, cropped and scaled images, and also set background images on the canvas. And today, we are going to be working with animations. Animations are what make your projects feel alive. Whether you're building games, interactive visuals, or cool background effects and animations like this, animations have you covered. In this episode, we'll be covering smooth movement, bouncing shapes like this, rotations, and even dynamic resizing, as you can see on the screen, how this square is rotating and growing and shrinking in size. Well, by the end of this video, you'll have the foundation to bring your canvas creations to life. So, without further ado, let's get on with the video. Okay, to start, we are once again inside our Coden's own compiler with index.html, a canvas tag with the ID myCanvas. I have styled it to have a border so that the canvas is visible to you guys, and a script.js where we have selected our canvas and gotten the 2D rendering context as well inside CTX. Now, let's start with the core idea about what an animation is. An animation is just a sequence of frames being drawn over and over again. And inside the canvas too, we'll be doing just that. First, let's write a function which will draw a red square on our canvas, and later we can go about animating it. So, first let's define where the square will be drawn. So its coordinates, let x equals 50, and then let y equals 50 as well. Now, we'll create a function called animate, and inside our function, first let's select a fill style for our square. So fill style equals red, and then let's actually draw our square with a fill rect method. So fill rect, and then inside the coordinates will be x and y, and the width will be 50 and the height will be 50 as well, so in order to actually draw the square. Now we'll call this function animate, and we can see that a red square is drawn at the position of 50 and 50. Now, after drawing our square onto our canvas, let's make it move continuously with the passing of time. And in order to move something on the canvas, we need to change the value of its coordinates, namely its x and y coordinate, or both. So first we will create a variable to determine how much we want to move the rectangle or the square in each frame of our animation, and we'll be moving it horizontally at first. So let's define a variable to determine how much it will move. So let speed x equals 2, and after that, inside we will increment the value of our x position each frame with the help of speed x. So if we run this function, animate function, over and over again each frame along with the passing of time, the value of our x coordinate will go on increasing by 2, and consequently the square will go on moving towards the right since the x value will be increasing. Now, in order to actually draw, or let's say use this function over and over again with each frame, we'll use a method called request animation frame, and this will take an argument of a function which will be animate. So you can see that our square is actually moving to the right, but it is leaving behind a trail of its previous drawings. And that is because we actually haven't cleared the canvas before we draw each square on the next frame, and which is moving towards the right. Okay, let's first comment this, and in order to fix that issue, we'll be using a method called ctx.clearRect. Now what this will do is it'll clear our canvas to the area that we define. So if we start from 0, 0, that is the starting point of our canvas, and if we want to clear the whole area of our canvas, we'll have to enter the canvas's width and the canvas's height. Now if we uncomment our animation, or let's say request animation frame, what will happen is it will clear the previous position of our square, and since the position of our square is updating in each frame, it is moving right by 2 pixels in each frame, it will look like our square is moving. So what will happen is it will look like it is moving with each frame, and that is how you animate inside Canvas. Now you might have gotten an idea about what request animation frame actually does. This method tells the browser to run a specific function, in our case it is animate, which draws our rectangle or square onto our canvas right before the next frame is drawn on the screen. So this is how we create smooth animations, by updating and drawing a tiny bit each frame. This gives us smooth and consistent motion, typically about 60 frames per second. And it is also smart, so it pauses automatically when your tab isn't visible, so it saves CPU and battery as well. So every time that the function animate runs, the shape shifts a little, which creates continuous motion like this. So as of right now, the x position of the square goes on increasing and the square goes off bounds. So let's make it bounce on the left and right wall as it hits the walls. And for that we have to add a condition inside our function. So after x plus equals to speed x, let's add an if condition. If x plus 50, which is the width of our square. Okay, let's first, this is quite distracting, so let's first stop it from moving. And if x coordinate, so our x coordinate of the rectangle, so let's say the starting position of our rectangle plus 50, which is its width, is more than or equal to the width of the canvas, that is this width right here, this point is representing this point. So if it is more than or equal to the canvas's width, or if the x coordinate is less than or equal to 0, that is this edge right here, the left edge, we'll make it so that the direction of speed x is reversed. And to do that, we have to do speed x equals minus speed x. Okay, let's see what happens when we uncomment this. Okay, right now the square is going right. Okay, it bounces off the right wall and it bounces off the left wall as well. And that is all because of this condition and this line as well. This way, if the rectangle touches the edges of the canvas, the direction is reversed, and that gives us the illusion that the square is bouncing. And now that we know about the basic knowledge behind animation inside Canvas, let's level up and make something more dynamic. A ball that moves around and bounces when it hits the edges of the canvas. And this time, we won't just move it in the x direction, we will move it diagonally. That is, we'll change both the x and y values. And for that, let's first delete all of this. Create x and y, we'll place this at 50-50. And let's say we'll create a let dx, this will be the horizontal speed, and let dy, which will be the vertical speed, so it will be 2. After that, we have to define a radius variable for our ball, which is in fact a circle, so 30. And after that, we'll create a new function called function animate ball. Now inside this we will first of all use clear rect so that the ball doesn't leave a trail behind, and this will be canvas. Okay, I should have put a comma canvas dot width, and then canvas dot height. Now after this we will actually draw the ball. So to draw our ball, if you remember, we have to do ctx dot begin path to tell canvas that we are going to draw a new shape, and then use the ctx dot arc method, which takes the coordinates of the center, which are our x and y values, and then after that our radius as well. So radius, our starting angle, and our ending angle, which is in radians. So we will use math.pi times 2, which is actually 360 degrees, and this will draw a ball. Now we'll use a fill style of orange. So let's say our ball will be of an orange color, and after that we'll use ctx dot fill. This will actually create the ball, and after that let's close the path. So ctx dot close path. Okay, before we start our animation, let's see if the ball is being drawn or not. So animate ball. Okay, I see what I did. I should have put a comma here, my bad. Okay, we have drawn our ball right here. Now in order to actually animate it, we have to first of all write the logic to update its position at each frame. So update position, and this will be x plus equals to dx, and then as for our y position of our center, we'll do at y plus equals to dy, and after that we'll write a logic for bouncing off the walls. So for that we will first write if x plus the radius is more than or equal to the canvas width, or the x minus radius value is less than or equal to 0, what we will do is we will reverse its direction. So dx equals minus dx, and kind of the same logic with the y value, but instead of width we'll place it as height. So canvas dot height, and this will be y, and then this will be y as well, and also our dy value will be changed. So dy. Now all that is left is to call this function again and again with the help of request animation frame. So request animation frame, and we'll call our animate ball function. So we can see that our ball bounces when it hits the edges of the canvas, and that is because of this logic right here. And the reason that we wrote plus radius is because the coordinates of x and y is that of the center of the circle, not of the edges of the circle at all. So if we for whatever reason miss out on radius, we'll be able to see that the circle first goes half inside of the right edge, and as soon as it hits the center it bounces back. So in order to accurately depict the bouncing ball, we'll have to add the radius value. So it will be radius. So we can see that it bounces off accurately. Okay, so that was how you move and bounce a ball around inside your canvas window. Now animations aren't just about moving things around. We can also rotate and scale our shapes dynamically. And for that, I'll have to first of all comment all of this out, or let's say remove all of the code for this. And we'll have to create an angle. So let angle equals 0. For rotation, we'll be using this value right here. And we'll create a new function called animate rotation. And inside this, we'll of course first use the clear rect value, since this is important for animation, 0, 0, and then canvas dot width and canvas dot height. Now after this, okay, I should have placed this with no space. Okay, now after this, we'll write a ctx.save, and this is to save our game state and prevent other things from rotating inside our canvas. Now after we do this, we'll have to use a special method called ctx.translate. Now in this, x and y values are entered, so canvas dot width by 2 and canvas dot height by 2. Now what we have done is with ctx.translate, we have shifted the center of our origin to the center of the canvas. So normally our points would start from 0, 0, which is the top left corner of our canvas. But with this, we have placed our origin at the dead center of our screen. And we will see how this will affect our rotation later on in the video. Now, after this line, we'll have to use ctx.rotate. Inside our parentheses, we'll type out angle. And after this, we'll first create a rectangle or a square. So let's create a square at first. ctx.fillStyle, which will equal to, let's say our square is purple, and then we'll use ctx.fillRect, and then -50, and then 100, 100. So the reason we have done -50 and -50 is to place our square at the dead center. If we hadn't done this and we had just done 0, 0, it would start from here. But if we do -50 and -50, it will start from right over here, and it will be placed at the center of our canvas with the width 100 and 100. Now after fill rect, what we will do is we will use ctx.restore at first. So let's see if our square is formed when we call the function. So animate rotation, and you can see that our square is at the middle of the canvas. Now in order to actually rotate this, we will have to increase its angle at the end of each drawing. So we'll have to do angle plus equals to 0.05, let's say. Now this is to control the rotation speed. And after that, of course, our final step is to use request animation frame to call this function again and again. So you can see that our square has started rotating. And that is because we rotate our square by a certain angle during each frame, and that angle keeps on increasing, so it keeps on rotating and rotating. And the reason that we used translate was because if we had done this, our square would be spinning around over there. So how ctx.rotate works is it makes the objects inside our canvas rotate around a certain point, and by default that certain point is the origin, that is 0, 0. Now if we had done this 50 and then 50, you can see that the rectangle, or let's say the square, is not rotating on its own axis, but it is rotating around this center, which we have set using ctx.translate. And if we hadn't done this as well, it would be rotating around this origin point right here. You can see that it's going round and round around this point. And to make the square rotate on its own axis, first we have set the axis to be the center of the canvas, and we have positioned the square in such a way that its center is on the axis as well. So the square center is the axis of the canvas. So that is why it is rotating around its center. And I hope that is clear to you guys. And not just using rotations inside animation, you can also use the ctx.scale property to scale the width and height of your objects equally. And for that, of course, I have to define a few variables. One is scale and one is a boolean, which we have used to either grow or shrink the size of this object, or let's say the rectangle right here. And I have used it inside the if else condition. If growing will increase its scale, and if it exceeds a certain scale, we'll turn growing to false, and that will make it decrease the scale value. So I'll not explain this code or type it out in detail since this video is getting too long anyways. So I do encourage you guys to try out this ctx.scale property along with the ctx.rotate property. And as always, I'll be leaving a source code of this down in the description below. You can check it out if you want to just take a look at the code, or if you want to look for your mistakes as well. And that was it for this video. You just learned how to bring your canvas to life through animations by clearing frames, moving shapes here and there, bouncing effects, and smooth rotations and scaling like this. These are the core building blocks for everything from games to interactive UI animations. And in the next episode, we'll make our canvas interactive by making it respond to mouse clicks and keyboard inputs as well. It is going to be a fun one, so don't forget to like, subscribe, and ring that bell so you don't miss it. And until the next time, bye bye and happy coding. Hey guys, welcome back to the HTML Canvas for Beginners series. Now, so far in this series, we have drawn shapes, added images, and even created animations on our HTML5 canvas. And today, we're taking yet another step towards leveling up our skill by making our canvas interactive. Now, in this episode, you'll learn how to handle mouse and keyboard inputs so that you can make your projects respond to clicks, movements, and key presses just like in real games. And stick around till the end because we are going to build a fun mini project where you can control a character using your keyboard. So let's dive right in. Now to start with, I am inside Codin Labs this time, not inside our compiler. Just a quick shout out, Codin Labs is a platform where you can build and test your code inside real-time environments just like this. And you can also check out what others have built and take inspiration from them, just like this heart particle simulation right here. This is also made from Canvas, and you can also check out each bit of the code and modify bits of code that you want to like to see what it results to. So do check out Codin Labs, check out what others have made, create your own creations with this create button right here. You can also save and publish after you have logged in to codin.com. And you can also check out your creations and your projects inside my projects and all of this. So do check out Codin Labs inside codin.com, and let's get on with the video. So we have a default boilerplate code here where I have created a canvas with the ID my canvas, height 400 and width 500 this time. I have given it a border of solid, and I have selected the canvas inside the DOM and gotten the 2D rendering context for it. Now, our canvas doesn't directly handle input because it is just a drawing surface, but the browser that runs our web pages can detect user actions. So we'll listen to the events on the canvas element using JavaScript. So inside our JavaScript, after we have done selecting our 2D rendering context, we can head over to add an event listener. So let's say event listener. And if we add our event listener to our canvas, it will be as canvas.add event listener. And then the event will be, let's say, click. Suppose we want to detect a mouse click. And then we will select the event. So inside here will be event, and then let's create an arrow function to say what we want to do when an event is detected. So let's say when a mouse click is detected on our canvas, we want to console.log canvas clicked, and then we can close this and then check it out. Okay, let's see our console. If we click our canvas, it will say canvas clicked. Okay. So that is how event listener works on our canvas. Now every time we click on the canvas, canvas clicked is projected onto the console, but usually we want to know where the click happened, and that's what we will do next. When our user clicks, the browser gives us details about the event, including the click position as well. So we can access that using something called event.offsetx and event.offsetY. Now, after this event listener, let's add another event listener. So, you know what, not adding another event listener, let's add inside this const offset x will be, let's say, x, and offset y will be y. Now this, or let's say these coordinates, will be provided by our event object, and after that let's console.log a pair of backticks clicked at x equals, this is the x position, so we'll be using our x variable, and then our y position as well. So y equals $, and then y. Now let's see what happens when we click on our canvas. So it says canvas clicked, and then it shows the position of the mouse click. So that is x equals to 2 and y equals to 7 6. And let's see what happens if we click near to the edge. So it says x equals 26 and y equals to 12. So these are getting closer to 0, 0, which is the top left corner, that is the starting point of our canvas. So as you might have already guessed, these values give us the position of the click relative to the top left corner of our canvas, not the whole screen. And this is super helpful for things like clicking on shapes, buttons, or characters drawn inside our canvas. Okay, now that we know how to get the mouse coordinates, let's make something that follows our mouse inside our canvas in real time, like a simple cursor effect. So let's add another event listener called canvas.addEventListener once again. And inside this we'll do not click but mouse move, since we want our object to track our mouse. So for this event, what we'll do is we'll create yet another function, and inside that function we will first of all track the coordinates of our mouse. So once again, const offset x will equal to x, and then offset y will equal to y, and these will be provided by our event object. Now since we want our object to track our mouse, we want to clear the canvas every time that our mouse moves, so that it can track the new position of our mouse and move the object, in this case which we are going to draw a circle, to that position. So first we have to use ctx.clearRect. So inside clearRect, we want to clear our whole canvas. So we will start from our origin point, that is 0 0, and then as for the area, we'll do canvas.width and then canvas.height. So this will clear the entire canvas every time our mouse moves, since this event listener is on mouse move. Now after that, let's draw our circle. So ctx.fillStyle will select as blue. So let's say our circle will be blue. And then after that, we'll have to do ctx.beginPath, since we are going to draw a shape. And after that, we'll do ctx.arc. This is our arc method, which we will be using to draw a circle at exactly the points of our mouse coordinates. So it will be x and y. And after that, let's say the radius will be 15, and the starting angle will be 0, of course, and then the ending angle will be math.pi times 2. So this is in radians, so this will be forming a full circle. After that, we'll do ctx.fill. This will actually draw our circle onto the canvas. So let's see what happens when we drag our mouse onto the canvas. You can see that a blue circle follows our mouse everywhere it goes. Now let's see what would happen if we hadn't cleared the canvas. So you might see that it will draw a line of blue circles everywhere our mouse goes, since we have not cleared our canvas every time our mouse moves. But if we clear our canvas, that problem is fixed, and we can see that a blue circle is following our mouse. Now this technique is the foundation of drawing apps, hover effects like this, and even games where the cursor interacts with the objects. And speaking about drawing apps, you can kind of simulate a drawing app if you replace mouse move with mouse click or mouse down. So mouse down. Now if we do mouse down, every time we click our mouse, a circle is formed on that place. So okay, let's close our console since it is detecting clicks as well. Let's comment this line in fact. Okay, now wherever we click, a circle is formed, and if you remove clearRect, you can kind of draw a circle everywhere you click. So let's say I want to draw a smiley face, so I would do click, click, these are the eyes, and then a smiley face like this. Pretty neat, huh? So this is the simple logic as to how drawing apps would work. Okay, now that we have handled our mouse input, let's move on to making something move using our keyboard, just like in a simple game. So for that, let's clear everything that we have drawn up until now. let's start fresh. So we'll start with our x and y coordinates to define our default positions when we don't move our keyboard. So it will be 200, and let y is 200 as well. Now after that, we'll first of all define a radius for our circle. So it'll be 20, let's see. And after that, we'll create a function which will actually draw our circle. So draw, and then inside we'll do ctx dot clear rect once again, since we want our rectangle, or let's say canvas, to be cleared every time we enter our keyboard input. So it will be canvas dot width, just like before, and canvas dot height. Now after that, we'll do ctx dot begin path. Okay, I realize I am just repeating code and I should not have cleared our code before. So it's ctx.arc, and then once again it's our center position, so x position and y position of the center of our circle, the radius of our circle, the starting angle, and the ending angle, which is just math.pi times 2. So it is 2 pi radians, and after that we'll do fill style. Let's say it's a red circle this time, so fill style equals to red, and then it will be ctx.fill in order to actually draw the circle. Now let's see if our circle is drawn or not if we call our draw function. So you can see that it is drawn. Now, so if you noticed before, when we added event listener, we did canvas dot add event listener, but in our case, keyboard events should be added to the document only, since the canvas doesn't automatically have focus. So we'll do document dot add event listener, and then for our case, since we want to detect our keyboard inputs, the event that we'll track will be key down. So key down, and then the event object, and after that our function to execute when the event is actually triggered. So first of all, we'll define a speed at which we want our circle to move when detecting keyboard inputs, and after that we'll do switch case. So if what we will be detecting is which key was pressed down, so in our switch we will do event.key, and inside our cases we'll do case. First of all, if the key is the arrow up key, so we'll do arrow up. Now if our arrow is up, we want our shape to move upwards, so we'll have to decrease the value of our y position. So y minus equals speed, and then after that we'll have to use break. Now after that, another case is what if the arrow key is arrow down. Now in this case we would have to increase our y value since we want the object to move down. So instead of minus equals, I'll have to do plus equals and then speed. Now after that, let's use break once again. Yet another case for our two arrows, which are arrow left, and this will be decreasing our x position since we want to move left, speed, and then break. And for our final case, let's do arrow right. And in this case, we will be increasing the value of our x position. So okay, I'll do plus equals to speed and then break. Now after we do all of this, after we increase the value, or let's say increase or decrease the values of our x and y position, we have to actually draw the circle onto the canvas. So after we do all this, we'll call our draw function. So draw, and at last let's draw our circle by default. Now let's click our canvas and let's see if our code has worked. So I'll be clicking the up arrow key. You can see that our circle is moving down, left, and then right. So you can see that we are moving our circle with the help of our keyboard onto the canvas. So let me just push this towards the top left corner. Okay, nice. So this is how we detect keyboard input inside Canvas, and that is the simplest way to add keyboard-based interactivity. Now, if you are familiar with WASD keys, instead of the arrow up, you can also add W, then A, then S, then D. So if I press on W, it will go Okay, WA. So this should be S and this should be A. Okay, now it's good. If I press D, okay, if I press onto the canvas and press D, it should go right, A should go left, then S should go down, W should go up. Okay, so that is how we can achieve basic keyboard interactivity. Now it's time for our mini project. Now as for our characters case, I'm going to be using VS Code and not our Coding Labs or coding compiler, since we do have to upload the character PNG onto our canvas, and this is stored inside my PC. So you can just open up a folder which has a character PNG, and inside it you can create an index.html and script.js and link them together. So inside this I'll open up CMD and just go to code space dot. Now this will open up our folder in VS Code, and as you can see inside index.html I have already prepared a boilerplate code which was at the start of this video. The only difference is that here is I have given a inline style as well, the border 2 pixels solid, and script.js is as it is. So let's click on go live and open up our live server. Now inside JS, what we'll have to do is we'll have to first create a character object. So first of all we have to create const character, and inside this we will be creating a new image object. So inside this we'll be referencing the source, so character.src will equal to character.png. Now after this we have to define the x and y coordinates once again. So x equals 250 and our y will equal to 150, and then let's say our speed will equal to 10 since we want to move the character on our canvas. Now we'll create the draw function. So function draw. Now what is the first step if we want to animate or let's say move character on our screen? That's right, we have to do ctx.clear rect since we want to clear our canvas during each movement. So 0 0 is our starting point, and canvas.width, and okay, this should be width, and then canvas.height. Now after that we'll actually draw our image onto the canvas. So ctx.draw image, and then the image that we'll draw is character, and then the position that we'll draw the image at is x and y. Oh, meant to type x and then y, and let's scale it at 100 and 100. So after that what we'll do is we'll add an event listener to our document once again to detect keyboard inputs. So for that I'll be pasting the code from our previous example where we moved a circle onto the canvas. So we'll do Control V and we'll have to make some changes. For example, we have already defined speed, and that's about it. We add an event listener to our document, we look for the key down event, and inside switch case we want to see what key was pressed down, and according to that we update the position values of x and y. Now after that the only thing that is left to do is to make sure that our character is drawn on the canvas only after it is done loading. So for that we have to do character dot on load equals draw. So this ensures that our character is drawn only after it is loaded. So you can see on our canvas our character of Mario is drawn. So let's make it its height 150 so that it seems a bit normal. Okay, now after that we will be detecting keyboard inputs. So let's try to move Mario on the canvas. So you can see that it moves on the canvas just well, and that is how you move your character on screen. Now if you don't want your character to go out of bounds like this, you can add a few if conditions onto each case. So as for example, for arrow up, if we do if y is more than 0 and then do this, we'll be able to see that it won't move up after it reaches y equals 0. And similarly we can add many conditions up onto S, A and D as well. Now I won't be typing them out physically. I want you guys to explore how we can keep Mario inside bounds. So that is for you guys to explore. Just like this, it only starts moving up if y is more than 0. So that is essentially keeping it bound to the upper bound of our canvas. And just like that, you have built your first interactive canvas game scene. Now, though it is not really that complex or flashy, it is simple and it is a start. From this, we will build a foundation so that we can explore our creativity. Now, if you are targeting mobile users instead of using key down and such events, we can also look out for touch start, touch move, and touch end events. They work similarly to mouse events but respond to finger touches. And that is how you handle mouse and keyboard input in HTML5 canvas. In the next episode, we'll combine all of the stuff we have learned so far on this series to make a simple shooting game. It's going to be a really fun project, so make sure you tune in. If this video helped you, hit that like button, subscribe to our channel, and comment what other games you'd like to build next. So until the next episode, bye bye and happy coding. Hey everyone, welcome back to the HTML Canvas for Beginners series, and today's episode is extra exciting because we're finally building our first mini project, a simple shooting game using HTML5 Canvas. Now this combines everything that we have learned so far: drawing images and shapes, animating objects, handling keyboard input, showing text on the screen, and even checking collisions. Well, we haven't really discussed about checking collisions in our previous episodes, but don't worry. I'll explain the concepts of checking collisions and explain how it works later on in the video. By the end, you'll have a playable game with our moving character which shoots the targets with bullets and a working score counter as well. And not only a working score counter, but if you want to develop a game over mechanism, you can even add a timer which runs out and game over appears on your screen. So, if you have followed this series so far, this is your reward. And let's get started with it. Okay, to start with, I have a folder called shooting game, inside which I have the player.png image of our character, which is an 8-bit version of Mario, and I also have index.html and script.js already present. Now let's start with opening this folder inside VS Code. So for that, I'll have to do code space dot after typing in cmd, and it will open up this folder inside VS Code. Now for our boilerplate, or let's say starter code, we already have, let's open both index.html and script.js. We have this boilerplate code where I have linked the script file, which is script.js, and have already made a canvas with id myCanvas, and I have given it a style of border 2 pixels solid. Now, as for our script.js, we already have selected the canvas with our DOM, so document.getElementById myCanvas, and const ctx we have gotten our 2D rendering context. Now to start with, I have not set our height and width inside the canvas tag inside index.html because we'll be setting that dynamically through the script.js file. So to set our width, we'll do canvas.width, and then we'll do window.innerWidth times 0.9. So it will be 90% of the width of our window, and as for our height, it will be 90% as well. So we'll do window.innerHeight and then times 0.9. Now after that, we will be moving towards first of all drawing our canvas. So let's go to our index.html and click on go live. This way we'll be able to see our canvas open up inside our browser. Now, okay, this is our canvas. Now let's set this to the side and set our code to the side as well. Now after that, we'll be painting our canvas dark. So for that, let's first of all create a draw function called function draw. Okay, now inside this we will be painting the canvas. So in order to paint the canvas black, we will have to first of all select a fill style for our 2D rendering context. So ctx.fillStyle will equal to first of all black, and then we will use ctx.fillRect to fill our canvas. So fillRect, and then it will start from 0 0 of course, and then it will span of canvas.width and canvas.height. So let's call our draw function in order to see the changes. So we can see that we have painted our canvas black as well. Now we will be beginning with drawing our character on the screen. So let's say drawing the character. Now in order to draw our character, first we have to load that character onto our canvas. So first of all, let's create an image object called const player. Now this will have our new image. So this will be an image object, and we'll set the player's source to be player.png. Well, let's see if we have character.png or player.png. Okay, we have player.png inside our folder, so we'll be naming it player.png. And after that, we will actually be drawing the player inside our canvas. So we'll do ctx.drawImage, and for the image that we are drawing, it will be the player's image, which we have stored inside player. So we'll be drawing the player's image, and then after that we'll draw it at some coordinates. Now first of all, before drawing our player, we'll have to define the player's width, height, and the x and y coordinates that we'll be drawing the player at. So before our draw function, let's create some variables called let player x. Now this will be the x position of the player. Let's say it will be positioned at 50, and let player y will equal to canvas.height by 2. This is half of our canvas, and let's say minus 50. So it will be positioned here. And as for the player's height and width, let's set it as const player width equals 100, and then const player height will equal to 100 as well. Now to use these values, we'll be using these inside draw image. So as for our x and y position, of course we'll be using player x and then player y. This will be the x and y coordinates of the player, and as for their height and width, we'll do player width and player height. Now the reason that our player is not being drawn on the screen is because we haven't accounted for the player's image actually loading onto our DOM. So for that, we'll do player.onLoad, and only when the player's image loads, we'll execute the draw function. So let's see what happens when we do this. So as you can see, when we do this, our player is finally drawn onto our canvas. Now after that, we will draw the targets on that the player has to hit. So the red squares, we'll be drawing the red squares onto our canvas. And for that, we'll have to first define an array which will contain all of the targets. So first we'll do let targets equals this empty array. Now after creating an empty array of our targets, we'll have to finally populate this array of targets with target objects. And for that, first we will have to select random coordinates on our canvas for the targets to appear. So for that, we'll have to create a function which will generate those random coordinates. So let's say get random, and this will have the minimum value and the maximum value. So this will be the range of from where we want to select the random value. And after that, we will create the function, and inside this we will create a return value, and inside we will use math.random. Now what this does is this selects a random number between 0 and 1. So 0 is inclusive and 1 is exclusive. So it generates either 0.1, 0.5, 0.11, 0.51, any value you might think of. And to actually make it select between our defined range, we have to multiply it by our maximum value minus minimum value. So this will be our range, and in order to make it actually start from the minimum value, we will have to add our minimum value. So let's say this generates 0.5. 0.5 when multiplied by our range will result in some value. And to make sure that it starts from the minimum value, so let's say it generates 0. If it generates 0, it will have started from 0 whether we multiply it from our range or not. So to make it start from our minimum value, we will add our minimum value. And after defining this function, let's utilize it to create some targets. Now for that, we will have to use a for loop. let's say I want to generate 3 targets at our canvas. So let's say I define a loop variable called I equals 0, and then I is less than or equals to 4, oh no, let's say 3, and then we will do I plus plus, and inside the for loop we will first do targets dot push, and then we will be pushing on target objects onto the target array. So we'll define an object which has the x position, and this x position will be determined by get random. So this will be a random value between 300 and the canvas's width minus 50. So the target's width and height we will be setting as 50. So in order to actually generate the targets inside our canvas from the range 300, this width 300, towards the end of our canvas, we will have to do, first of all, our starting value 300 and our ending value, which will be canvas.width, but we also have to account for the target's own width. So we'll have to subtract the 50 value. So after that, it will come our y coordinate, oh not semicolon, it will be comma. The y coordinate will also be determined by the get random function. So inside get random we will do, first of all, 0, since it will be the starting point of our height. It will be 0 from way over here all the way down to our height, but still we have to account for the height of our target as well, so it will be minus 50. So the starting position is 0, and then the ending position will be canvas dot height minus 50. Okay, now after that, let's set the height and width of our targets. As I said before, we'll be setting it as 50, and then height will be 50 as well. So this will be our target. Now let's see if our targets array is being populated or not. So console.log, let's say targets.length. Now when I check our console inside our browser, we can see that 4 is outputted onto our console. So it means that the targets array is being populated as well. Oh, so in order to generate 4 targets, we'll have to do less than or equal to, and I forgot that it's starting from 0, so I did 3. But if you want just 3 targets, you can do 2 as well. So this will be generating 3 targets. Now, after actually populating our targets array, let's draw them on our canvas as well. So for drawing our targets onto the canvas, we'll have to go inside the draw function and then create a for each for our targets array. So for let's say our targets, now targets dot for each. Now for each target, which we will be defining by t, we will be drawing it onto our screen, or let's say our canvas. So ctx dot fill style, let's say our targets will be red, so we'll be defining them as red, and then ctx dot fill rect. Now this is what actually draws our targets onto the canvas. So for our x position, we'll do t.x, which will reference to this x position right here, which is random, and then for our y position, we'll do t.y, and then after that we'll be defining the target's width and height. So we'll do t.width and then t.height. Now you can see that these targets are randomly generated onto our canvas, and to prove that, let's type a semicolon. This will make the web page reset. So you can see that they are at a different position. Now if I once again reset the web page, you can see that they are at a different position. So this was how to draw the targets on the screen. Now after drawing our targets on the screen, let's make our character move up and down in its designed path. Now for that, we'll have to update the character's position every time we press arrow up or arrow down. So first, in order to do that, we'll have to define an object. So for that, we'll have to do const keys. This will have our arrow up and arrow down key, and those arrow up and arrow down key will have the truth and false value set, so that we can move the character based on those values. Now after defining our object, we will do document dot add event listener to detect our, first of all, key press down, so key down. And when our key is down, we will first of all detect that key and set the key's value, that is e dot key, inside our keys object as true and false. So if a key is down, we will set its value as, first of all, true. But let's copy this line once again. Okay, I'll first of all maximize this so that you are not distracted by the canvas over there and you can see this properly as well. So what we have done is here, when the key is down, we will record that key inside our keys object. So let's say I press down the arrow up key. This line here will record that arrow up key inside this keys object and it will set its value as true. Now for the key down, or let's say when we lift our finger from the arrow up key, that means the key is not being pressed anymore. In order to record that, we will be detecting the event as key up. And when that key is up, that means when we are no longer pressing that key, the value will be false. Okay. Now, after that, we will be defining the player movements logic. Now, we will be doing that by defining a function called update player movement. So, function update player, let's see. Now, inside this, we will have a speed for the player. So, speed equals 10. Let's say we want the player to move with the speed of 10 pixels per second. And for that, we will have to define some conditions. Now, if we will access the keys object right here, if the keys object's arrow up key is detected, or let's say it has a true value, what we will do is we will decrease the player's x position. So player y will be decreased by the factor of its speed. So minus equals to speed. And for the player to move down, if the keys object has a value of arrow down, that's the arrow down value is true, the player y value will be increased. So it will be plus equals speed. Now this will enable us to move our character up and down. Okay, now in order to actually see the effects of this update player function, we will have to call it over and over again so that we can decrease the player's position according to the arrow up and down keys. Now for that, we'll have to create another function called game loop, and we'll be calling this game loop function over and over again. Now inside game loop, since we will be calling this function over and over again, we will have to clear the canvas each time. So clear rect ctx.clear rect will be clearing the entire canvas. So we'll use canvas.width and canvas.height. And after that, we'll be using the update player function. So update player. And after that, we'll be finally drawing our player and the entire canvas once again. So we'll use the draw. And instead of using player.onload equals draw, we'll use player.onload equals game loop. And to finally call this function over and over again, we will use request animation frame. So request animation frame. What function are we going to call? So game loop. Now let's see if this has worked. Now this is our canvas. I'll press the arrow up key and the arrow down key. So you can see that our player is moving along with the arrow up and down keys flawlessly. This is a nice step. Now the next step is to actually shoot bullets from our player. And for that, we will have to create another array. Now instead of the targets array, we'll have to also create let bullets equals empty. So the empty array will be let bullets. And in order to actually add bullets into the array, we will have to create an event listener. Okay, let's say we want our player to fire when we press the spacebar. Now to do that, we will have to add an event listener to the document itself. So for doing that, we will have to create document dot add event listener and then key down. And for that key, we will execute a function, we'll do if e dot key will equal to a space, which is a space bar. Let's say it'll push our bullets. So bullets dot push, and then it'll push a bullet object, and we have to define the x and y position of this bullet object as well. Now this will not be random. The x position of the bullet will be relative to that of the player. So player dot x plus player dot width. So this has to come from the front side of the player. So we'll do player dot x, or not dot, so let's say player x, this is the x position of the player, and player width, this is the width of the player. And as for the y position, we'll be defining it as player's y position as well, but we'll be adding the player's height. Not just player's height, we'll be adding the half of the player's height. And let's say we want the bullets to come out of the top position of our player, so let's say here. So we'll have to decrease some value from our player height, so -2. Now what this will do is it will set the bullet's position to right about here as relative to our player. And after that, let's define the height and width of our bullet. Now in order to actually look like a bullet, we'll have to define its width as 10 and the height will be 5. So let's see if our bullets array is being populated as we press the space key. So after this, let's console.log the bullets array's length. So bullets.length. Now let's see our game. Okay, when we do inspect, okay, let's reload this so that it appears on the full screen. Now when we reload this, let's press space. Okay, 1 2 3 4. That means our bullets array is being populated as we press on the spacebar. So once again, I'll press the spacebar and it'll output to 5. Now this comes from the line 21 of our JS file, that is console.log bullets length. That means we know for sure that our bullets array is being populated. Now to shoot out the bullets from our player, for that we will have to first of all draw those bullets inside of the draw function. So after targets, let's say it'll draw bullets as well. So bullets. And for that, we'll have to use once again a for each function. So bullets dot for each b, and for each bullet we will draw it onto the canvas. So ctx dot fill style will equal to yellow. Let's say our bullets are yellow, and then fill rect. Now this position will be relative to that of the object. So b dot x, this is the x position of the bullet, and then b dot y, and then b dot width, and b dot height as well. Now let's see if the bullets will be drawn. So when I go to our game, let's close our console and reload this. So when I press space, you can see that the bullet is being drawn on top of each other. Many bullets are being drawn on top of each other, but these bullets are not moving forward. Now to make those bullets move forward, we will have to create yet another function and call it inside our game loop. For drawing that, we will have to create a function called update bullets. So we will be doing that right below our event listener, which actually adds those bullets onto our bullets array. So first we will create a function called update bullets, and then inside this we'll be doing bullets dot for each. Now we'll be taking the bullet object themselves and its index. So b is the bullet object and I is its index. So for that we'll be creating a function. Now we'll use this index to remove the bullet object from the bullet array once it is off bounds from the screen. So for that we will have to use b.x plus equals 10. Oh, so I should have actually created an arrow function. So once our bullet has been fired, or let's say has been added inside our bullets array, let's say it has to be fired from our character and go across the screen. So we'll be calling this update bullets function inside our game loop over and over again in order to move the bullet from our starting point towards the end of the screen. So that will be achieved by this line right here, b.x plus equals 10. So this will update the bullet's position in each frame. And after doing that, we will have to delete the bullet from the bullets array as well once the bullet has traveled from our canvas to beyond our canvas. So for that, we'll do if b.x is more than canvas.width. Let's say we will splice the bullets array. So bullets.splice and then the bullet object's index and then 1. This will remove the bullet object from the array. So that is done. Now let's see what happens when we load our game. So our character is moving up and down, and if I press space, oh, I forgot to call it inside our game loop. I'm sorry for that. So after we update our player, we will update our bullet as well. So update bullets. Now let's see what happens when we fire the bullets. So you can see that it is moving across the screen, but it is not, it is hitting our targets, but we have not moved on to collision detection just yet. So it is successfully generating and then moving across our screen. Now, if I press on spacebar for a long while, you can see that a long range of bullets is actually being generated. Now, in order to add a delay for that, we will have to use set timeout. So inside our, let's say before our event listener, which adds our bullets onto our bullets array, we'll have to define a variable called can shoot. So by default, we'll be setting this variable to true. And let's say if the key is spacebar and we can shoot, then only we'll be adding our bullets and let's say consequently shooting our bullets. Now in order to actually add that delay, we'll have to use set timeout. So after adding our bullets inside our array, we will turn can shoot to false, and then we'll be using set timeout. And inside set timeout, we'll be creating a function which will turn our can shoot value to true, but only after 200 milliseconds. So this will add a bit of a delay and it won't cause a continuous range of bullets. So you can see that it has a delay as well. It's not shooting continuous bullets like we had seen before. Now that's that. And you might have also noticed that our character is moving off screen as well. Now in order to actually clamp our character onto the bounds of our canvas, we will have to tweak our update character, or let's say update, what was our function? Update player function. So instead of just updating the speed, let's add a condition before we update. So inside player y's minus value, let's say it will only update the player's position if the player y value is above 0. So what this will do is it will prevent the player from moving furthermore upward. So you can see that as long as I press the up key arrow, the player is not moving out of bounds and the upper position. And to do the same in the lower position as well, we'll have to add a condition to this if condition. So if the key is arrow down and the player y position plus the player's height is less than the canvas's height, then only we'll be updating the position. So this will clamp our character down as well. So up it is clamped, down it is clamped as well. Now let's move on to detecting collisions and actually deleting these targets once our bullet hits the targets, like this. If our bullet hits the target, both the bullet and the target will disappear. And for that, we will have to check for our collision. Now let's go about understanding the AABB collision. So let's say we have two rectangles. One is rectangle 1 and the next is rectangle 2. Now the two rectangles don't collide if one is completely to the left, completely to the right, similarly above, or below the other. Now, for the collision to happen, we have 4 conditions that have to be fulfilled. And for that, I'll be explaining them using this Excalibur. Well, the 4 conditions are these. And keep in mind that you don't have to remember all of these, you just have to think of them commonly. So if I have rectangle 1, the first condition says that the right edge of rectangle 1 must be past the left edge of rectangle 2. So this is one of the conditions that must be fulfilled for a collision to happen. And you can clearly see that the 2 rectangles are clearly colliding. But what would happen if I move this rectangle to here? The right edge of rectangle 1 is clearly past the left edge of rectangle 2, but you can see that they are not colliding. That is where our second condition comes in. The left edge of rectangle 1 must come before the, okay, this should be right. That is, the left edge of rectangle 1 must come before the right edge of rectangle 2. So this is the condition. The left edge of rectangle 1 comes before the right edge of rectangle 2. Now, we can't solely depend on this condition only, since in this case as well, the left edge comes before the right edge of rectangle 2. But you can see that they are clearly not colliding. So both 1 and 2 must be fulfilled. Now, what about 3 and 4? Now, if I place this rectangle way over here, you can see both of these conditions are fulfilled, 1 and 2. Now, when looking at the x-axis, we can see that the right edge of rectangle 1 must be past the left edge of rectangle 2. We can see that the condition 1 is fulfilled. Now, what about the second condition? We'll be able to see that the left edge of rectangle 1 must come before the right edge of rectangle 2. That is also true. The second condition is also fulfilled. But these rectangles are still not colliding. But if we move this over to here, we'll be able to observe the third condition as well. The top edge of rectangle 1 must be above the bottom edge of rectangle 2. So this. Now you can see that all 3 of these conditions will be fulfilled. 1, 2, and 3. But what if this happens? What if our rectangle 1 is above rectangle 2? You can see that the top edge of rectangle 1 is clearly above the bottom edge of rectangle 2, and both the first and second conditions are also true, but we can see that they are clearly not colliding. So for the collision to happen, all of these conditions must be fulfilled, and the last condition that must be fulfilled is the bottom edge of rectangle 1 must come below the top edge of rectangle 2. So finally, all 4 of our conditions are fulfilled. Now you can try this for yourselves. You'll be able to observe that for these 2 rectangles to collide, or let's say to touch or overlap, all of these conditions must be fulfilled. You can try this out on your own. You can draw 2 rectangles and try to, place them one above the other and check all of these conditions to see if they're true or not. What you will find is all of these conditions will be true. And we will be doing exactly that inside our code as well. We will be placing these conditions inside our code as expressions. So let's get on to our code. I hope you understand AABB collisions properly, and now we'll be looking that in our code. Okay, so inside our code we have made it up until the point that we shoot bullets from our character and the bullets move across the screen nicely, and we have also clamped our character on top of our screen and bottom of our screen as well. Now all that is left is to detect the collision and make the targets disappear when the targets are hit. So inside our code, below our update bullets function, we will create another function which will be called function is colliding. So is colliding, and then after that it will accept 2 parameters, and they are the parameters for which we have to check if the objects are colliding. So what it will return is a truth or false value, and here we are to use the 4 conditions that we just discussed before. So first, it is the left edge of the first object must come before the right edge of the second object. So the right edge is defined by b.x, since this will be the starting position of our rectangle plus the rectangle's width. Now if you'll notice, if you start from a point and add its width, you will arrive at the right edge of a rectangle. If suppose our rectangle starts from here, right? This is our starting coordinate, this is our x coordinate. But if we add the width to our x coordinate, we'll end up at our right edge. So When we have to define our right edge, we do that by adding its width. So b dot width. Now this is one of the condition. The left edge of one rectangle must come before the right edge of the other rectangle. And another condition, the right edge of the first rectangle, that is a dot width, must come after the left edge of the other rectangle. And these are for our horizontal ones. So the top edge of our rectangle must be above, or let's say less than. So you might notice that inside our canvas, as we move further down, the y value keeps on increasing. So if we want a edge to be above, it should have a lower y value. So the top edge must be above the bottom edge of the other rectangle. So b dot y, in this case we'll add on height. So it's b's height, so b dot height, height. Now after that, the final condition of our 4 conditions is that the bottom edge of our first rectangle plus a dot height must be below the top edge of our other rectangle. So b dot y. So these are our conditions, and we'll check if a collision has occurred yet. So let's say we have a function to check collision. So function check collisions, and then inside our function, what we'll do is we will first of all check collision of our target and of our bullets. So first of all, we want to see if our bullet hits any target at all. So for each bullet, for each bullet inside our bullets array, we'll check if it has hit any target. So we'll have the bullet itself and the bullet's index for deleting the bullet later on. So index, and for each bullet, what we will do is we will check if it has hit any targets. So targets dot for each t, and then the target's index. For each, we will do if is colliding. So let's say if the bullet and the target are colliding, what we will do is we will first of all remove the bullets from the bullets array. So bullets dot splice the bullets index and then 1, which means that we will delete that bullet from that index, and then we will remove the target as well. So targets dot splice the target's index, so t index, and then 1. Now let's see if that occurs when we actually play it in our game. So okay, inside our starter template, so let's say I first of all, we haven't called check collisions inside our main function, that is a game loop. I forgot about that. Update bullets, after that we have to check for collisions as well. So let's see. You can see that as soon as the target hits the bullet, first of all a collision is being detected, and then the target is being removed from its array and the bullet is being removed from its array as well. So once again, let's reload this and let's confirm that a collision is occurring. So first of all, here we will go inside check collisions, and let's say if is colliding, we will say console.log bullet hit the target. Now after saving this, I have autosave turned on. Now I'll inspect this and go inside our console. So let's see. Okay, bullet has hit the target, bullet has hit the target once again, and bullet has hit the target. You can see that it is outputted 3 times onto our console, meaning that our collision detection is working just fine, and our logic of deleting the bullet from its array and deleting the target from its array is working nicely as well, as you observed just now. Now after doing this, what now? You may see that after all of our bullets have hit all of our targets, there are no targets to hit anymore. So let's draw a function that makes the targets respawn after all of them have finished. So doing that is fairly simple. We just have to go on to the place that we had our initial filling targets logic. So we have here, okay. Now we'll create a function called refill, or let's say redraw. And inside this, we will just copy and paste the same logic. So this for loop will be copying and pasting, and we'll make it so that in the place of game loop, after request animation frame, we will check if the target's length reaches 0. So if targets dot length will equal to 0, what we will do is we will execute redraw. So now let's see if that happens. Okay, let's finish our targets. 1, 2. I apologize if my aim sucks. Okay, you can see that after our targets are finished, or let's say we completely hit our targets, new targets are spawned. Now that is nice. Now all that's left is to add a score counter and a timer to make things interesting. So first we'll be moving with adding our score counter. So let's move on to our code. So inside our draw function, after bullets, what we will do is we will add our score display. So score display. Now for that we'll do ctx dot first of all text align. We want to make sure that it starts from the left, which is by default, but later when we'll print the game over screen, this will come in handy. So the ctx dot fill style will be white, since we have a black background, so white. And after that, the font, let's say, will be 20 pixels, and okay, I meant to type out 20, 20 pixels and Arial. Now after that, we'll finally fill our score. So ctx dot fill text, and then inside we'll use a set of backticks. And first we have to draw a score value, or let's say we have to define a score value. So here we'll say let score equals 0 at first. Now after that, what we'll do is we'll move over to our draw function, and inside fill text we'll say score, and then a set of colon, and then we will use our $sign and then a variable. So score value will display upon here, score. After that, it's coordinates. First of all, we'll do 10 units on the x-axis, and then let's say 16 units on the y-axis. And every time we hit a target, we'll draw a logic, or let's say we'll define a logic to update the score. So in check collision, if the collision happens, we'll say score plus equals 10, let's say. Now let's head over to our code. Okay, that's too small. So in our code, I have noticed that this 20 pixels should be together and not apart. So you can see that the score value is visible and a bit large. Now let's see if our score increases when we hit the targets. So you can see that the score increases by a factor of 10 whenever we hit the target. Now the score is 20, and now the score is 30. Now this way you can just keep on hitting targets and keep on increasing your score. Okay, there is not much of a fear factor to this game. This is definitely a nice game where you can shoot targets and increase your score, but let's add a fun factor to it as well. So what we'll be doing is we'll be adding a timer mechanism to this game, such that a timer will run, and as soon as you finish a batch of targets, the timer will be increased by a factor of few seconds, but it will still keep counting down to 0, and once it reaches 0, the game will be over. So we'll be creating just that. Now to do that, we will be needing to create some variables up here where we have defined a bunch. So after score, let's say we will have a variable called let game over, and this will be true only when our time reaches 0. So first of all, let's create another variable called total time. This will actually be our time. So this will be in seconds, okay? And after that, we'll do let start time equals null, first of all. So this start time will be initialized only when the game starts. So let's say initialized when the game starts. And here below, inside our draw function, we will add a timer display as well. So where is our draw function? Okay, after score display, we will add a timer display. So timer, sorry, display. And after that, we'll say let time passed. What did we create up here? We have total time and start time. Okay, let's say let time passed will equal to a date object. So date dot now minus the start time, and this will be divided by 1000 to account for milliseconds. And then after that, we will create another variable called time left, and inside this we'll use math.max, so that this will choose either the values between 0 or a math.ceiling value of the total time, which is our starting time, that is 10 seconds, minus the time that has passed. So time passed. Now this way we can show the time left on our canvas. So we'll do ctx.fillText, and then inside backticks we'll do time, and then we will display our time that is left. So time left will be displayed, and then S to symbolize seconds, and we'll display this at canvas.width minus 120, let's say, and then the Y position will be 26. Now to actually end the game when the timer runs out, we'll first create a condition inside our draw function itself, and it will be, let's say, end the game when timer runs out. Now if our time left reaches 0 or less, so less than or equals to 0, we'll turn game over equals true. Now all the way down to our game loop, what we'll have to do is to prevent the game from continuing even if the timer runs out, we have to add a check. So only when our game is not over, so if not game over, then only we will be running these functions. So all of this will be inside if not game over. Let me format this real quick. Okay, and then after that, inside our functions of firing as well, we'll have to add a check. So inside our game loop, I forgot to add one thing. We have to first of all add a start time. So if our start time is not declared yet, so if it is not null, so if it is null, I mean, the start time will equal to date.now. So that's that. Now in the place where we add our bullets onto the canvas, we'll have to first of all wait for the game not over. So and can shoot, and the game should not be over. So game not game over. Okay, let's first of all check if our timer is running. Okay, it says not a number. Okay, let's check what we have done wrong. Okay, so turns out I forgot to add a parentheses here, so now it should work. Okay, it says 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so it has just stopped drawing. So our game over feature is working well. Now let's make it so that every time the target's dot length is 0, first of all we will redraw, and then we will add some time onto our time left. So first of all we'll do time left plus equals time left plus equals 3, let's say, and let's say our timer starts from 20. So here it is 20. Okay, I forgot to see if it worked or not. I was too focused on the projectiles. Okay, it is not working, so we'll just add some time onto our total time value. So instead of time left, we'll add it to total time. Okay, now let's see if it adds some value. Okay, you can see that some time is being added as soon as we finish this batch of targets. And this is the entire game. You have to quickly finish the targets, otherwise you'll run out of time and the game will be over. And the score is projected right there. Now finally, let's make it so that once the game is over, it will show a game over screen instead of just a blank canvas. So let's head on to our code and form a game over function. So below our update player, we will form a show game over function. So function show game over, and then inside our function, what we will do is we'll first select a fill style for our canvas. So fill style, and let's say it'll be a bit grayish black. So RGBA values will be 0, 0, 0 and 0.8. And after that, we'll use fill rect to actually color the background of the canvas. So fill rect, and then it will be 0, 0, and then canvas dot width and canvas dot height, since we want to cover the entire canvas. Now after that, what we will do is we'll use some text to say that the game is over. So ctx dot fill style will be white. Okay, didn't mean to do that. And then ctx dot font, the game over font should be actually quite big, so we'll use 60 pixel font, and it will still be Arial. And then we will align the text to our center. So text align equals center, and then we will actually fill the text. So ctx dot fill text, the text will say game over, and then it will be filled at canvas dot width by 2, and then canvas dot height by 2 as well. So it will be filled at the center of the screen. And let's say we want to show the score as well. So ctx dot font, let's say we want to show the score at relatively less font size, so 30 pixels, and Arial. And then after that, we'll use fill text. So fill text, and inside fill text we'll use a set of backticks, and then final score, and the final score will be displayed by our score variable, so score. And then after that, let's say we'll position it at canvas dot width. Okay, still I forgot to go outside. Okay, canvas dot width by 2, and then canvas dot height by 2 plus 80, since we want this to be below the game over text. Okay, and that's it. So let's see what happens when the game is over. So I'll cut to where the game is over to save a few seconds for you guys. Okay, now the game should be over. 3, 2, 1. Oh, I forgot to call this function. Okay, my bad. Here, if the game is over, we should call this function. So it should be game, or let's say show game over. Okay, now let's see. Okay, let's just set the time to like 3 or something and see about that. So let's say it will be 5 seconds. Okay, now let's see. So it says game over, but it doesn't see the score. I wonder why. Okay, I forgot to mention fill text, the capital. Okay, now we can properly see our score as well. So it says final score is 0. So let's actually play the game and see if it accurately displays the score or not. So okay, we have 3 seconds. One more. Oh, okay, my final score is 40. Okay, so we have a clear game over screen as well. Now all that is left is to define a restart mechanism so that the game can be restarted when it is over. So first of all, let's add some text to say that we can restart the game. So let's say ctx.fillText, press R to restart the game, let's say. And let's say it is positioned at canvas.width by 2, so the center of the screen, and canvas.width height by 2 plus 120. So it should say, yeah, I'll cut to it. Okay, press R to restart the game as well. Okay, now let's actually define the restart mechanism. So inside, okay, let's create a function right over here below update player, or let's say below redraw. Where do we have redraw? Okay, where we have redraw, we will restart the game. So function restart game, and this will first be resetting the score value. So score will equal to 0. The bullets will be empty, so bullets equals an empty array, and the targets will be empty as well, equals an empty array once again. The game over value should be false, otherwise the game won't play at all. And then start time should be once again set to date dot now parentheses. This will reset the timer, so say resets timer. And then after that, we will redraw the targets. So we'll call the function redraw, which draws our targets once again onto the canvas. And then we will finally call the game loop. So game loop. Okay, let's see what happens when the game is over. Okay, let's play for a bit. It'll run out anyway. Okay, it says press R to restart the game. And okay, I haven't actually called, I realize that I haven't actually called event listener. So first of all, let's add it here, shall we? So it will be document dot add event listener, and it will be key down. And then as for our key, so let's say E. So when the key down is detected, if E dot key is equal to restart, that is R key, and the game is over, the game has to be over for the restart key to work, we will finally call restart game. Okay, this should be a function, so right here. Now let's check our function if it works or not. So let's play until that time. Okay, the game is over. Now if I do R, it restarts the game. So this is how our game works. Now if you want it to increase the difficulty level, you can always reset the score to a lower value. But let's say I want to actually make the game playable, so I'll put this to a 20, and let's see if our game mechanism is working all fine. Okay, so we start from 20, and if I move the arrow keys, our character will move up and down. Okay, I missed that. And if I do once again, you can see that the timer increases and our targets respawn as well. So let's see how high of a score can I get. Okay, I didn't mean to miss that. 6 seconds. Okay. Oh, shoot. Okay. Once again, restart. Okay, the game is working just fine. But you can see that the timer starts from 30 once again. So we'll have to reset the timer as well inside our restart game function. Okay, inside restart game, we'll say, what was our value once again? It was total time. Okay, the total time will equal to 20. Okay, that should do the trick. And that was how you do or create a simple game like this, where you can play as a character and shoot down targets with the help of bullets. Now, of course, you can add different mechanisms where you can even make the targets move towards the player, and you can detect the collision of the player and of the target, and if that happens, you can mark it as game over. And that was it for this video, guys. You've just built your very first HTML5 canvas shooting game. You have combined everything that we have covered: drawing, animation loops, keyboard input, and collision detection as well. The 4 pillars of every 2D game engine. Now, if you enjoyed this, you can try expanding it. Like I said, you can add more targets, or you can make the targets move towards the player to and detect collision and enable a game over feature. You can prevent the player from being eliminated by hitting the targets and dodging the targets like this. So there are many options that you can do, and you can make your own 2D games as well. So if you liked the video or found the video helpful, don't forget to drop a like, subscribe to our channel, and share your own version of the game in the comments below. I can't wait to see what you create, so I hope you do that as well. And as with other videos, of course, with this mini project as well, I'm going to be leaving the source code down in the description so that you can check it out over in Coding Labs. So until our next video, bye bye and happy coding.